When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Awqaf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Awqaf can bless our community with a legacy of care.
Peninsula High School here. We've got a cohort of learners. We used maths paper 1 yesterday, and today we'll be focusing on grade 11 maths paper 2. So Mr. Kevin will be the facilitator for today, and it is today that we start this session on a very high note. The box was successful, and I hope that some of this motivation and this positivity that's in the ether will motivate you in grade 11 for your final maths examination. How's it a round of applause for our boys that perform really well. My name is Hasnain Abdullah. I'm from Awqaf South Africa. We are one of the organizations that have brought together a host of organizations, other organizations, to host this program. We have been doing these maths workshops since 2015 to assist our learners in achieving great results in mathematics. We hope that through these interventions you can produce more engineers, scientists, accountants to solve some of the contemporary problems that faces our country and its very fragile economy. So this program is hosted by Awqaf South Africa in association with the Department of Basic Education, the Kway Institute, ISkill, and it is hosted here for the first time in Cape Town at the South Peninsula High School. So for those via YouTube and Facebook, please give this video a like, share, subscribe to our platform. In this way, you will be notified of future content from our side. I'm going to be calling on Mr. Baker from South Peninsula High School. He is the principal and he's the driving force behind the school. So we'll call on Mr. Baker and he can give us a round of applause.
Good morning everybody. Morning to the students from Spine Road High School, Livingston, and also South Peninsula. It warms my heart when I see all of you here this morning on a Sunday morning after spending 6 hours at SP yesterday. Give yourself a round of applause for your efforts. To the viewers online from all over the country, welcome to you. Today is the day of paper 2, and according to my maths teachers, they are telling me that this is the paper where our students struggle a little bit. And so hopefully today, with our presenter, a well-known, revered maths teacher, I'm sure today you are going to be exposed to lots of tips. You know, the whole thing about shortcuts, they say shortcuts sometimes in maths can knock you a little bit, but I'm sure that Mr. Khota has everything under control, and I'm sure that all of you will enjoy the session today. I just want to say something about yesterday. Yesterday, I admired your resilience. And I want to say this to you. You are the matric class of 2024. If you can show that resilience every week, you know, using one day of that weekend and to intensify your revision, then matrics of next year, 2024, you are going to do very well next year. So it's about being exposed to the maths, but I think it's also about getting you to develop the necessary resilience and the grit to cope with matric. And I want to say, students, that getting A's and B's in matric, it's not that difficult to do it, provided that you are working hard. And so to the matric class of 2024 who are present here today, as well as those of you online, I wish you well with today's session. And also to our presenter, Mr. Khota, thank you very much to you for the effort that you are putting in to assist our grade 11 students. And then also our sponsor, Awqaf. Thank you for bringing this program to our students. All the best for today, students. Thank you.
So that was Mr. Baker, the principal of South Peninsula High School. We are coming to you live from Cape Town. Online participants, please hit us up in the comments. Let us know from which province you are connecting to us from which school. Please show us some love and let's keep the conversation flowing. So without delay, we are going to be calling on Mr. Khota. He is the facilitator for the session for today. His high energy and some of his streetwise sensibility is going to assist you and show you some of the tips and tricks in order for you to be successful in your examination. Just one important note I would like to share that all participants, whether you're online or in person, Awqaf will be hosting a competition for grade 11 learners that have participated in this workshop. So we will be awarding hard cash to you. First prize winner could walk away with about up to 2,000 Rand. Mr. Khota from KW could double this. So for the competition, first prize, second prize, and as well third, as well as the most improved learner. So we'll open up this portal in January 2024. We will need your June results as well as your final results. And all communication will happen via email. We'll have a program via our live stream to share some more information and rules about the competition. So please do give our YouTube platform a like and subscribe to it so you don't miss out on this opportunity. And the winners will be announced in the new year 2024. Okay, another important thing is for those that are in person, we have got the Awqaf banner over here. So this is going to make it easy for you to access the Awqaf website. So you come during your lunch break, there is a little QR code. You scan that, that'll give you access to the Awqaf website. Why? You need to get access to the Awqaf website besides being able for you or your parents to donate to some of Awqaf's Awqaf projects via a crowdfunding application. We do have a maths workshop page that has all of the videos of the session for today and some of the past papers. It also has links to the YouTube platform. It's going to make it easy for you to opt into that platform. So it's going to make it easy for you to get access to lots of the resources that we do have. Bear in mind that we have hosted this workshop in May, August, and this is the final one in October. So enough speaking from my side. Mr. Khota is going to be doing all of that today. I'll be just sitting here in a very passive and supportive role. So we'll just call on Samit now to log in Mr. Khota's launch sequence. Take the show away, Samit.
Eight, seven, six, five, 3, 2, 0 post-launch flight operations.
Good morning, good morning, good morning, all our grade 11 learners here in the beautiful Fair Cape, as well as all our online learners from all over South Africa. Everybody's walked in today positively motivated. Everybody's energized after last night's super win. We number one in the world in rugby, and inshallah, we're going to be number one in mathematics. Say Ameen. Right, I hope you guys are fueled, hydrated. You've got your scientific calculators. You've got your books. I hope many of you had the opportunity yesterday to go through all the work that we did yesterday. And just to refresh your memory, we're doing paper 2 today. Scientific calculator, writing pad, refreshments and stationery, and whatever you need to hydrate yourself. And the program today, in fact, we're going to start off with analytics and the introduction to trigs in our first. We're going to try and finish as much as we can from paper 2, and then hopefully we have enough time at the end. I'm going to finish finance and probability, which we left out yesterday. But in any case, guys, it's a big day today. It's a big day. Let's get fired up. Let's get fired up. Open up your books. We're starting with analytics, analytical geometry, paper 2. So just to tell you, Right, let's look at our paper 2, and I'm going to show you a road map. Paper 2, we all know, data handling. Guys, we're not even going to touch that today. I'll tell you why, because that's the easiest topic. Mean, median, mode. To calculate your average, to do a scatter plot, a S-curve. Data handling worth 20 marks. Number 2, you're going to get 2 by analytics questions. It's going to be worth 30 marks. 15, maybe 20. Maybe 15 and 12, about 27, between 27 to 30 marks for 2 analytics questions. Then you're going to have your, you're going to have trigs. Then we go into trigonometry. So put this down. There we go. You're going to have your trigonometry. So 30 and 20, that gives us 50. Another 30 marks here. 30 to 40 marks in trigonometry. And then we have Euclidean, your circle geometry. Right? Your paper, so 30, 60, 80, maybe 20 marks if your paper is out of 100, or the balance would be maybe you might get another. Sometimes your paper is out of 100, sometimes your paper is out of 150. Let's just double check here from your national paper. If you're writing a provincial paper, your total marks would be 150. So trigs, then comes your trig graph. So let's add on another 20. So 30, 20, 50, 80, 100, and 50 marks there. And that will give you your 150 marks for your math paper 2. So what we're going to do is we're going to score full marks there. We're going to score full marks there. We're going to try and score full marks there and full marks here. Right. Remember, we're aiming for 100%, not 100 out of 150. But if you get a minimum of 70%, you good. If you get a minimum of 70%, you good. But we're going to aim destination, distinction. Right. So let's see if our army, our battalion of grade 11s, onliners, how we doing. I hope you guys are energized and ready for today. Patient Matlangu, Botse High School. Good morning, morning. Yes, we good. Maths is a banger. Let's get started, guys. We're starting with paper 2, analytics. Let's get started with the formulas first. Okay, let's go. What formulas do you need to know? Here are your formulas. Guys, you need to memorize these formulas. I want you guys to memorize them from now till the end of grade 12. The first formula that we require. The first formula is the distance formula. The distance between 2 points. So say we had that in analytics, and you had a straight line going there, and that is point A, and that is point B. Let's say that is the point 2 and 10. Let's say that's -6 and -4. So the distance of line AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And there we go. That's the length of line AB. So we use the distance formula for length. We use it for proving shapes. If they want you to prove a shape, like a square, or a parallelogram, or a kite, or an isosceles triangle, or a 90-degree triangle. So whenever we're proving shapes, we can use the distance formula. That's not the only formula we can use, but we can use the distance formula. Number 2, the gradient. Now this is very important. The gradient formula. The m of line AB is equal to, we all know by now, y2 minus y1. You can call this, if you want to, x2, y2, and call that one x1, y1. You can call any one x1, y1, x2, y2. You'll get the same answer. Okay, so y2 minus y1 over x2 minus x1, that is our gradient formula. And when do we use the gradient formula? Obviously, number 1, we use it for calculating the gradient of a line. We also use it for proving shapes. How do we use the gradient formula for proving shapes? For parallel lines. Those two lines means parallel. What do we know about parallel lines, guys? The gradient of the line 1 will equal to the gradient of the second line. Yes or no? You know that already. You've been introduced to this in grade 10 already. Perpendicular or 90-degree lines. We know that the m of line 1 multiplied by the m of line 2 must equal to -1. Yes or no? Good. When else do we use the gradient formula? For the angle of inclination. The angle of inclination. And that we use tan theta. We don't use sine, we don't use cos. Tan theta is equal to the gradient of that line. So if this angle here was angle theta, guys, it's always from your x-axis up until where it touches the line. So there we go. Tan theta, we use it for the angle of inclination. We also use it for collinear points. What does collinear? If I want to prove that A, B, and C lie in a straight line, then I got to prove for collinear points that the m between A and C must equal to the m between B and C. So if this gradient is equal to that gradient, that means all 3 points lie in a straight line. Agreed? I hope you're taking this down. I hope you are taking this down. So our first formula, to recap, is our distance formula. The second formula we have is our gradient formula. Grade 11 learners here in-house at the back, are we all good? Thumbs up there. Are you guys following? We on track? You online? Excellento. Right. We got 2 more formulas, guys. 2 more formulas, and then we start with an exam model. 2 more formulas, and then we start with an exam model. And we're going to crack this. Once we're done with that, we hit trigonometry. Okay. Onliners, are we there? Big shout out, Hillcrest High School, KZN. Mr. Slope, if your quality is bad, it means your internet is slow. Good morning, Munir. Petite High School. Ethan, welcome, welcome, welcome. Baby boy Bobo, Ratang Tuto High School, Northern Cape, in the house. Welcome, welcome, welcome. Right, guys, I'm clearing the frame. We got 2 more formulas. We got 2 more. We did the distance. We did the gradient. What do you think your next formula is? Your midpoint formula. Your midpoint formula. So if we want to find the midpoint of a line, we use x1 plus x2 over 2 and y1 plus y2 all over 2. But what if the midpoint is given to you? What if this is point A, that is point B, and that is point C, and I tell you that C is the midpoint. And I give you C's cone. This is very important. This is very important. I need you to pay attention here. If I tell you that is 4 and 6, if I tell you this is 1 and 2, I want the coordinates of B, X, and Y. Now, if the midpoint is given, and you're going to see, we're going to use this. We are going to use this in the exam model. If the midpoint is given, what formula do I use to get the midpoint? I want B's coordinates, guys. I want B, the coordinates of B. What formula? Do I still use this point, this formula? No. Because I don't have x1. Remember, this is x midpoint. That's y midpoint. We can call that one x1, y1. We can call that x2, y2. So I can't use this formula here. x1 plus y. So we use this formula here. We change it to an equation. We say x midpoint is equal to x1 plus x2 over 2. Now we have an equation. And we use y midpoint is equal to y1 plus y2 over 2. That's the formula we use. That's the formula that we use. So let's do it. Let's all do it together, guys. We want to find out what is B's coordinates. So x midpoint, I'm going to circle it. What's x midpoint? 4. Is equal to x1, which is x. We don't have it. Plus x2 plus 1 over 2. Y midpoint is 6. Is equal to y1, which is y. Plus y2, which is 2 over 2. Can you see why we use this formula now? Grade 11s? Right. Now all we need to do is solve for x and y. So multiply by 2, multiply by 2. So 8 is equal to x plus 1. X is equal to 8 minus 1 is 7. Multiply this side by 2. Multiply that side by 2. 6 times 2 is 12. Is equal to y plus 2. Y is equal to 12 minus 2 is how much? 10. And there we go. There's B's coordinates. Here are the coordinates for B, 7 and 10. B's coordinates is now 7 and 10. Okay. Learn. You're going to use this right until grade 12. Inshallah, God willing. When we mentor you until the end of grade 12, I'm going to be reminding you of all this work I taught you this year. Remember, we have, for those of you who have just joined us, we have 4 more workshops or 5 more workshops next year for grade 12 to prep you fully. Hopefully, by the time it comes to prelim time, you would have mastered it. You know it at the back of your hand. You can memorize it. Remember, what did we say yesterday? We want to finish the 3-hour paper in how many hours? 1.5 hours. If it's a 2-hour paper, you want to finish it in 1 hour, in half the time. Why? Because you want to do the same paper twice. So you got to know your work. You got to know your stuff. You got to be a boss. Your pen must just move. The last hour or 15 minutes, you're just checking whether your algebra is right, whether you multiplied out correctly, and whether your signs are correct. Okay, that's your midpoint formula. One more formula, guys. One more formula. Formula 3. Here's formula 4. The equation of a straight line. Now, what if I gave you a line? I told you that the gradient of this line, that's negative over negative, is positive. So let's say the gradient of this line is equal to 2. And I gave you one pair of coordinates. Let's call this point PQ. And I told you that P's coordinates is 10 and 4. Right, I want the equation of this line. I want the equation of this line. Now, many of you, we know that the equation of a line is y is equal to mx plus c. Yes or no? Right. Have you seen this formula before? Now, the reason why I'm not using this formula here, because then I must do it 2 steps. I must first find c, then take c and put it back into here. We can use y minus y1 equals m into x minus x1. So when you're given the gradient and you're given a point, you can just use this formula. You'll still get y is equal to mx plus c. Check. Let's do it together, guys. Put your pens down. Onliners, I hope you guys are following. So y minus y1, y minus 4 is equal to m2 into x minus 10. Do you all agree with me? Yes or no? Good. Now we multiply out. So y minus 4 is equal to 2x minus 20. Now take the 4 on the other side, and here's your final answer. Y is equal to 2x minus 20 plus 4 minus 16. And there we go. We use one formula to get the equation of the straight line. If the gradient and a point is given, it's a very, very useful formula to use. So take this formula down. Take this formula down. How are we doing, onliners? How's our cohort? How's our battalion? How's our soldiers from the rest of South Africa? Amandla. Away. Cultura High School. Takalo Dinong Matebe. Welcome. Ravensmead High School, Western Cape. Welcome, welcome, welcome. I hope our learners here from Roshni Islamic School is also in here. Islamia, Johannesburg Muslim School, all the different Association of Muslim Schools also being part of our program. Yes, work smart, not hard. The beauty of mathematics is that you don't need to do 100 problems of the same type. You just need to know how to unpack a problem and make sure that your algebra is correct. You can't study for math. You can't study math. You're going to study the process. Memorize the process, but you can't study math. And there we go. We're done with our formulas. Just to show you, to prove to you that you can't study math. You know if you study, you guys say if you study, you won't fail. Am I right? That's what you say. If we study, we won't fail. So that means the converse must also apply, that no study will equal to fail. So let's call that equation number 1 and let's call that one equation number 2. Let's solve this simultaneously. So what do we have? We're going to add the two equations. So we got no study plus study is equal to no fail plus fail. Now we got two terms. So what do? We take out the highest common factor. What's that? Study. What am I left with? No plus 1. Study divided by study is 1. On this side, what do I have? What's my highest common factor? Fail. What do I have? No plus 1. I divide this side by no plus 1. Whatever I do on the left, I do on the right. What have I just proven? Study equals fail. You got to understand your work. You got to master the work. You can't study. You got to apply yourself. I see some of you taking this down. I promise you this is not worth 5 marks. And remember, the purpose of mathematics is to simplify your life. Not complicate. Have you ever opened up a paper and saw there for 6 marks? Complicate. The question always said simplify. But many of you complicate your life so much, you don't even know what you are doing. You just see numbers. We can even prove that all women are evil. You know that. You know we can prove, Hasanain, you know we can prove women are evil. Yep. Women equals time and money. But we know that time equals money. Isn't time money? Don't they say time is money? Therefore, women equal, if time equals money, so now instead of time, I can substitute it with money. So I'm going to have money times money. So x times x is x squared. So money times money is? So women are equal to money squared. But we also know that money is the root of all. So therefore women equal, instead of money, what can I put? The square root of evil, money, squared. Don't forget the square. Square and square root cancels out. Therefore, women equal evil. So we've just proven using surds that women are evil. No. Women are not evil. Shame. We feel you guys sorry. Shame. Astaghfirullah. We won't say that. I'm going to hell. I told you I'm going to hell. I'll meet you there. I'll be there first. I'll entertain you. I'll welcome you in. Let's go, let's go. Let's give you an exam model. Come on, come on, come on. Back to math, back to math, back to math. There we go. Let's call that 0. That's our x-axis, and that's our y-axis. And this is point P, Q, R. Okay. I give you this angle here. I tell you that angle is angle theta. I give you this angle here on the top, and I tell you that is angle beta. I give you P's coordinates as 4 and 30. I give you R's coordinates, that's 4. Let's call that 10 and minus 6. And let's call Q's coordinates negative 8 and 2. Okay, so take this one down. And we're going to ask you a whole host of questions on this with 30 marks. How many marks? 30 marks on analytics. You have to get it right. Why? Because I've given you the formulas. All we have to do is apply the formulas. Gradient formula, distance formula, midpoint formula, equation of a straight line. Parallel lines, gradients are equal. Perpendicular lines, the product of the gradients equal to -1. Angle of inclination, tan theta is equal to that. That's it. That's your toolbox. Now, take that to answer all the following questions. So, let's see. Question number 1. I want the gradient. They'll ask you, obviously they're going to give you some marks, some mahala marks. So, they want you to find the gradient of PR. The gradient of PR. Question number 2, the equation of PR. Question number 3, find angle theta. Question number 4, find angle beta. Question number 5, an equation of a line parallel to PR, passing through Q. One more question. Question number 6. If S, X, and Y, no, let's do this. If PQRS is a parallelogram, if PQRS is a rhombus, find the coordinates of S, X, and Y. If S is in the first quadrant, let's give you mark allocations here, guys. Onliners, I know you guys are all taking this down. Onliners, square root of evil. Hi, boss. Tafelsig, Munir Samsudin. Tafelsig, big shout out. Mitchell's Plain. I love Mitchell's Plain. Tafelsig, Lentegee. I was there at Spine Road. Many years. I stayed in Muizenberg. I used to travel every day to Spine Road. Love the Cape. Fair Cape. I had a good friend there as well, Mr. Najjar. He was here yesterday. Mr. Riyad Najjar, the ex-principal of Spine Road High. Mr. Ahmed Chotia from Glendale. Cedar, Mondale, Westridge, Eastridge, Tafelsig, Lentegee. Right, let's go. Let's give you mark allocations, guys. The gradient of PR3, the equation of PR4. Find theta, 2. Find beta, 5. The equation of a line parallel to PR passing through Q, 4. If PQRS is a rhombus, another 4. Let's see. 4, 8, and 5, 13, 14, 15, 19. This set of questions is worth 22 marks. This set of questions is worth 22 marks. Let's get our full 22 out of 22. Are you ready, grade 11s? Let's start. Onliners, are you ready? Some of you have started already. Okay, let's go. Right, we're answering question number 1. Let's answer question number 1. They want the gradient. So here are your answers. The answer to question number 1, the gradient of PR. So you say the MPR is equal to, you must put your formula down. You get a mark for it. So MPR is equal to Y2 minus Y1. I can call anyone X1, Y1. So let's call this X2, Y2, PR, X1, Y1. So let's go, guys. Let's do it together. Y2, 30. Minus Y1, minus 6, plus 6. Over X2, 4, minus 10. So MPR is equal to 30 plus 6 is 36 over 4 minus 10 minus 6. So MPR is equal to positive divided by negative is a negative. 36 over 6 is 6. And there we go. That is your first 3 marks. Marks for Mahala. You're going to see when we hit trigs and we start doing reduction. Ooh, It's going to be fun. The fun is coming. Identities, reduction, general solution, solving triangles. We got some quite shortcuts for you. Some lekker hacks for you coming up.
Hello.
Okay, let's go. The equation of PR. So we got the M. This is what I want you to do, guys, in the exam. Now that you got your answer and you know you're right, you go and say the M of this line, not M the midpoint, M the gradient is negative 6. Go and put it on your diagram. The minute you get an answer, put it on your diagram because you work from your diagram, not from calculations. But you got to make sure that your answer is right.
Mr. Khota, how is it going there?
Excellent. We're on fire here, bro. And our learners are working. These are our workhorses. You saw our Bokker yesterday. Right until the end, bleeding face and
Cooking.
It doesn't matter. Guys, don't ever think you're not going to get a hiding. Of course, there are a couple of questions that's going to bust your nose or crack your cheek in math. It's okay. What's the important thing at the end? It's the person who holds up the trophy.
Yes.
And that's where we at, guys. Our Bokker showed us yesterday how true grit. They played with heart. So you play math with heart. This is mental rugby here, brah.
So, Mr. Khota, we're going to have our own champion and campaign ambassador. Rory Sang will be with us today.
Yes.
10:30.
Oh, wow.
So we're going to take the levels through the roof today.
Yes. The learner who got 100% last year through our program, he's going to be here during break. He's studying at UCT. I think he's doing astrophysics or something. What is he doing?
He's an actuary in the making.
He's an actuary in the making, guys. He got 100%. You know what a feeling that is to clock math? You are on. The equation of PR. The equation we got. Now listen to me. Now here comes that hack that I showed you or that new formula. Check here. Kykie, my bro. Al die dinge moet sy los van die week se geld en die blik se kos en as ek is dan okay, now let me not rap in Afrikaans here. Right, here we go.
Mr. Khota,
Kykie.
we don't speak Afrikaans like that, eh? Please.
Let's go. So now what do? We go y minus y1 is equal to m into x minus x1. Remember that formula I showed you? Grade 11s. Do you remember the formula I showed you? Yes, bro. Machana, let's do this. Right, so you can use any coordinate. Which one do you guys want to use, P or Q? Right, let's listen to you for a change. So let's use 4 and 30, and we got the gradient, negative 6. So y minus 30 is equal to negative 6 into x minus 4. Yo, bro, let's do this, hey? So y minus 30 is minus 6x plus 24, right? So y equals minus 6x 24 plus 30, 54, bro. I'm drinking iron, bro.
Lanky, bro.
It's Sunday, guys, it's Sunday. And there we go, y is equal to minus 6x plus 54. Y equals minus 6x plus 54. Go to your line and put your equation in. Yeah, don't worry. Maths has a tendency to make you lose it. Let's erase. I hope you took it down. Onliners, how are we doing? Onliners. Pink waving. Hey, Masipu Malele, Fishhook, Simonstown. I remember your school. I was there many years ago. Masipu Malele. Cape Town, Fishhook, in the house. Yes, Ayam Sulani. Welcome, welcome, welcome. Ogbe. Brendan Makazi. Priceless boy. I'm glad you're enjoying it. Right, let's go, let's go. We are erasing. Find theta. Come on, the angle of inclination. I want you to do it. Let's find angle theta. Let's do number 3. There's theta. So tan theta, watch here, tan theta is equal to the gradient of which line? Which line does the arrow touch? QR. Very good. So tan theta is equal to y2 minus y1. 2 minus minus 6 plus 6 over minus 8 minus 10. So tan theta is equal to 2 plus 6 is 8 over minus 18. Theta is equal to shift tan, 8 over negative 18. And what do I get? Minus 23,96 minus 24. Now wait. You put minus 24, no problem. You include the negative sign. Hear me out. So put minus 24. But now remember, watch here. Watch here. Theta is an obtuse angle. Yes or no? And the answer that I get is acute. It's less than 90, right? If I ignored now the negative in the final answer, I get 24. And 24 is less than 90. So how do I get an acute from an obtuse or an obtuse from an acute? We know angles on a straight line add up to 180. Am I right? Adjacent supplementary. So therefore, theta is equal to, obviously, we're going to say 180 minus 24. So theta is equal to, so we can just add on to get a positive answer, 156. And there we go, theta is equal to 156 degrees because it's the obtuse angle. The 24 degrees is that angle there. That angle is your 24. The acute part of that line, of that angle, the acute part is 24. The obtuse part is 180 minus 24, which is 156. Correct? Thumbs up? Good. So we got 3 and 4 is 7 and 2 is 9. Now let's find angle beta. Let's find angle beta. Now it's a lot of, it's big marks. Beta is hanging in the air. There's no x-axis there. I'm going to show you a Kwai way of solving beta. A new move. Right, watch here. Watch here. Okay, I don't have space there on the top, so I'm just going to redraw it here. Pay attention, grade 11s. You need to know this. You're going to be tested on this year as well as next year. Grade 12 is the same work. Only thing, you do one more component which is called circle analytics in grade 12. So you'll be writing on normal analytics plus everything here we're doing. Remember, everything we do this year, you're writing next year as well. So you are basically matriculants already in the making. Okay, watch here, watch here, watch here, watch here. Keiki, look here. Right, watch, watch. That's angle beta there. Pay attention. This is point P, 4 and 30. This is point Q. I'm just redrawing it here on the side. Minus 8 and 2. And we got the gradient of this line, which is minus 6. Right, pay attention. Right. Beta is hanging in the air. Beta is not against your x-axis. So come and show you a move. You make another. Remember, you got a x-axis here at the bottom, right? What you do is you make a false x-axis through that point. Make another x-axis. That line is parallel to that. And what you do, listen to what put your pens down. Check what I'm doing. Check what I'm doing. Put your pens down. I'm extending this line up because the gradient at the bottom is the same as the gradient on the top, and I'm extending this line there. Why? Can I show you something? Because x-axis, remember angle of inclination is x-axis up, x-axis up. So that means when I use the gradient of this line, which is minus 6, it's going to give me that angle there. And I'm going to call that angle beta 1, the big angle. Then I'm going to use the gradient of this line and that, and I'm going to call this angle angle beta 2. So the big angle minus the small angle is going to give me that angle, and that angle and this angle are vertically opposite. Can you see how I'm getting to B? Can you see how I'm getting to beta? Remember, if this big angle here, is 100, and the small angle here is 80, how much is B? 100 minus 80, which is 20. Am I right? And this angle and that angle are vertically opposite. That's how we're going to get to it. So now, pay attention. Let's do that again. Let me show you what I did. Let's go through it one more time. Right. Let's go through this. What did I do, guys? I made a false axis through that point, and that is parallel to that. Yes or no? What did I do? I extended that line. I extended this line. This angle is my big angle. This angle is my small angle. And beta is going to be big angle minus small angle. Can you see that? Right, so let's do the calculation. Let's do the calculation. Now, I'm just going to erase this because I don't have space. I'm going to work here at the bottom, right? Let's do it together. So we're going to call the big angle beta 1. We're going to call the small angle beta 2. We know beta is going to equal to big angle minus small angle. Right, so let's go. Tan of beta 1, tan of angle beta 1 is equal to the m of line PR. PR. And we got the m. So tan of beta 1 is equal to minus 6. Beta 1 is equal to shift tan minus 6. Shift tan minus 6. I get 8 minus 80,53, but it's obtuse, plus 180. I get 99,5. Beta 1 is 99,5. Zakir, can this be my final answer? No, I only found the big angle, am I right? I need to find the small angle. So tan of beta 2, you show all this calculation. Tan of beta 2 is equal to the m of which line? PQ. Do I have PQ's gradient? No. So tan of beta 2 is equal to y2 minus y1, 30 minus 2 over x2 minus x1, 4 plus 8. So beta 2 is equal to, you can do this one shot on your calculator, shift tan fraction, 30 minus 2 is 28, 4 plus 8 is 12. I get 66,8. And I leave 66,8 because it's acute. It's 66,8. I leave it. I don't say 180 minus. So what is B equal to now, guys? What is B? What is beta equal to? Beta is equal to beta 1 minus beta 2. Beta is equal to 99,5 minus 66,8. Here comes the moment of truth. Our final answer. Beta is equal to 99,5 minus 66,8. And I get 32,7 degrees. And there we go. You're going to get 5 marks for that. Maybe even 6. 2, 4, 6. Learn this. Remember, guys, remember the angle of inclination is from your x-axis up in an anti-clockwise direction. Right, so we found beta, so we're done with that, we're done with that, we're done with that, we're done with that. The equation of a line parallel to PR passing through Q. So if you've taken this one down, you can start with number 5 already. Start with number 5 already. BBS High School, welcome. Four Ways High School, welcome, welcome, welcome. Why don't we keep the decimals to answer Ogbe? We don't keep the decimals, you round it off to 1 decimal place. Angles you do to 1 decimal place. Okay, let's do number 5, guys. Let's see how sharp are you. Do number 5. Do number 5. An equation of a line parallel to PR. So parallel, the minute they talk about parallel, what are they talking about? Gradients. And the gradients are equal. An equation of a line, y is equal to mx plus c. These things should ring in your head. So they say the equation of a line parallel to, we're answering question number 5 here on the top. So the m of PR is equal to minus 6. So the m of your new line will also equal to minus 6. Why? Because they are parallel. They tell you it's parallel. So the m of line 1 must equal to the m of line 2. Passing through Q. So what's Q's coordinates? -8 and 2. Guess what happens now, guys? What do we have? We got the gradient and we got a point. Which formula do I use? The y minus y1 formula that I gave you earlier. Can you see how many times that formula gets used? Let's do it again. So now we're going to go. Therefore, the equation of the line, therefore, y minus y1 is equal to m into x minus x1. Y minus 2 is equal to minus 6 into x plus 8. Y minus 2 is equal to minus 6x minus 48. Remember, we multiply it out. Y equals, here's your answer. Y equals minus 6x minus 48 plus 2 minus 46. There we go. We're done. And we're en route to getting full marks, to totaling this question, to getting full marks for analytics. And then we go into trigs. That's where the fun starts. So take this one down. And we got one more question, the last question for 5 marks. What was the last question? If PQRS is a rhombus and S is in your first quadrant, find the coordinates of S, X, and Y. Yes or no? Right. Let's do number onliners. I hope you're still online. Shout out to my younger brother Nelani, Oathkeeper. Big shout out there to Nelani. Morning, morning, morning. Baloy. Kyle Baloy. Hola. Ita. You good, you good, you good. Let's go, let's go, let's go. Watch here. Right. S, X, and Y is in the first quadrant, so maybe somewhere there. Let's just put it there. S, X, and Y. And they tell you PQRS is a rhombus. So let's just join that. Okay. Find the coordinates of S, X, and Y. Now, what do we know about a rhombus? We know that the opposite sides are parallel. We know that all 4 sides are equal. But that's going to be a lot of work. There's a couple of ways to do it. We can find the gradient of this line, the gradient of that line, equate the two, and we get equation number 1. Then I can find the gradient of that line and the gradient of that line, and I equate the two, and I'm going to get equation number 2. Then I'm going to do simultaneous equations, and I'm going to solve for X and Y. And like I said, bada bing, bada boom, we're going to get it. However, there's a shorter way. That's a lot of work. I'm not saying I'm wrong. I'm just saying I'm long. It's a long way, not the wrong way. Look, there are many ways to get from Joburg to Cape Town. We can either take the N1, which is straight, or we can take the garden route through Durban and take us a week. So let's go. Some of you are still babalas.
You quoted Yon. It's a
Yo. That breath, that was last night, 2 o'clock in the morning's breath, brah.
And yesterday was some flatulence that we
Yeah, yesterday somebody literally dropped a bomb on us yesterday.
Oh, please, guys. No.
What's the easier way to do it instead of using those gradients? Come on, grade 11s. How about Don't we know that the diagonals of a rhombus bisect each other? So that piece is equal to that. So that's the midpoint. And then that piece there is equal to that piece there. Yes or no? The diagonals of a rhombus bisect each other. So I'm going to find the midpoint here because I got both the coordinates. And that same midpoint is the midpoint of that line there. And in 2 steps, I'm going to find the coordinates of x and of s, x and y. So let's do this. Watch here. I'm answering question number 6. So the midpoint, let's call M the midpoint. The midpoint of PR. The midpoint of PR is going to be x1 plus x2 over 2, y1 plus y2 over 2. So x1 plus x2 over 2, y1 plus y2 over 2. 4 plus 10 is 14 over 2 is 7. 30 minus 6 is 24 over 2 is 12. That means my midpoint of this line is 7 and 12. Is 7 and 12. That's my midpoint, M the midpoint. Now I want to find S, X, and Y. Now I'm going to be using this line here. So now I'm going to say, to find S's coordinates, I'm going to say X midpoint is equal to X1 plus X2 over 2. That second formula I gave you. And Y midpoint is equal to Y1 plus Y2 over 2. So X midpoint is 7 is equal to X1, which is X, plus X2 over 2. Y midpoint is 12 is equal to Y1, which is Y, plus Y2 plus 2 over 2. So S's coordinates times 2 times 2, 14 equals X minus 8. X is equal to 14 plus 8 is how much? 22. On this side, 24 is equal to Y plus 2. So Y is equal to 24 minus 2 is 22. So therefore, S's coordinates is 22 and 22. What do we know? Purely coincidental. Why? So we didn't have to use gradient, make equation 1. Gradient, equation 2. You could have even used distance, because they're all the same. But then it would have been a whole page of calculation. All we did, we used the midpoint of PR, and then we used this formula. So it's 2 steps. Step 1, step 2, I just continued over from there to there. It's 2 parts, and you got your answer. And there we go. So please remember your properties of quadrilaterals. Let's end off on a killer question for 8 marks. Remember, it was out of 22 marks, am I right? Let's give you an 8-mark question to make it out of 30. Find the area of triangle PQR. Find the area of triangle PQR. Guys, this is the last question for analytics. Find the area of triangle PQR. So I'm erasing that, guys. Let's see who's sharp. I want the area of triangle PQR for 8 marks. It's a non-90-degree triangle, so we got to use the area rule from trigonometry. What is the area rule? The area rule is half of a side. Here's the area rule for any non-90-degree triangle. Half of a side times another side, half the length of one side times the length of another side times sine of the included angle. Area is equal to half of a side times another side times sine of the included angle. It has to be the included angle, the angle between the two sides. I would say, guys, triangle PQR, let's find angle R. Let's call that angle R1. We're going to have to make another false x-axis here. That's why it's so many marks. Because we have to first find angle R. We actually don't. Guys, you know what? What a smart question. Actually, we don't. If you wanted to draw a false x-axis, you could. But there's another way of doing it, which is now, remember, we always look at the shortest way to get to an answer. Check here. Check here. We got this angle here. Didn't we get this angle here? Or no, we didn't. Man. Because we got this angle here as, we got this one here as 24. So that means this angle here at the bottom is 24. Vertically opposite. And that's a triangle. Check here. That's a triangle. So I can find R1. So that means I got 24. That angle is 24. I need to find this angle here. Then that angle and that angle is vertically opposite. Then I can use sum of angles of a triangle and I can get to R1. Are you following me? So I think that's the better way. We need R1. Then we're going to need the distance of QR. Then we're going to need the distance of PR. Then we're going to apply this formula. Remember, because area is equal to half of QR times the other side, PR, times sine of the included angle of angle R1. Work it out, guys. Yeah. You could find PQ and PR. No problem. You could find, we already got angle beta. We've already got angle beta. You can then just calculate the distance of PQ. So, very good, area is equal to half of PQ. PQ, if we're using that side, and PR. And we're going to use sine of angle beta. So you could have used that one, or you could have used that one. This one is going to be easier. Why? Because we already got angle beta. So that means we only need to find two distances here. Two lengths. So find me the length of PQ, find me the length of PR. So we're using trigonometry. We're doing the area rule from trigonometry, from trigs. For non-90-degree triangles. So, what is PQ? PQ is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So, PQ is equal to the square root of x, we're looking at PQ, x2 minus x1 all squared plus y2 minus y1 all squared. PQ is equal to, put all this in your calculator, one shot, the square root of, open brackets, negative 12 squared plus, open brackets, 2 minus 30, negative 28 squared. 4 root 58. 4 root 58. Guys, leave it in third form. Don't convert it to decimals. In analytics, we don't use decimals. What did I say, guys? In analytics, we don't use decimals. Unless we get it in our final answer. But then too, if you don't want to use decimals in your final answer, you don't need to. You can leave your answer in third form. So that is PQ. I want PR. So PR is also equal to x2 minus x1 all squared plus y2 minus y1 all squared. We're looking at P and R. So that is the square root of, so PR is equal to x2 minus x1 10 minus 4 squared plus minus 6 minus 30 squared. So PR is equal to, let's go to our calculator. Open brackets, 10 minus 4 is 6 squared plus, open brackets, minus 36 squared. And I get 6 root 37. Right. Therefore, the area of triangle PQR is equal to a half of PQ times PR times sine beta. So that is a half. What is PQ? 4 root 58. What is PR? 6 root 37. Times sine. What is beta? What did we calculate beta to be? How much? 32,7. And here's the area of triangle PQR. Here's your answer. So let's go. That's a half times 4 square root 58 times 6 root 37 times sine 32,7 close brackets, boom. 300,32 or 31, 300,31, 300,3. Let's leave it as 300,3. Because they're talking about area, you have to put units square. Square units. Area is square. If you don't put the square units in, if you don't say square units, they minus 1 mark. You've got to put your units in because they're talking about area. Kwai, there's your 30 marks. Your first 30 marks for analytics. How's our time? Right. So according to our program, we're moving exactly according to schedule. We said analytics and introduction to trigonometry. So let's do some trigs. Not too much. We're going to go on for another 20 minutes into trigs. Let me explain to you the entire trigs, what you need to know. Remember, you need to know, you need to navigate, you need to have a map in your mind. Obviously, on any journey that you embark on, you need a map. If you don't know where you're going, well, you're going to get lost. So, let's give you the map. Let's show you trigonometry, what you need to know. So, let's go. Let's clear the frame. This is your entire, I'm giving you your entire trigonometry at a glance. This is your checklist. All you're going to do is just tick it off to see whether you know your work. So I'm clearing the frame here. Let's go. We're now into trigs. So put the heading Trigonometry. There we go. Trigonometry. What does the word trigonometry mean? Nometry means the study. And tri means triangles. So trigonometry means the study of triangles. Why do we study triangles? We study 2 types of triangles, 90 degree and non-90 degree. Remember, trigs is broken up into 90 degree triangles and non-90 degree triangles. For 90 degree triangle, to solve the triangle, what do we use? SOHCAHTOA. You guys know SOHCAHTOA? Good. Oh, hell, another hour of algebra. Yes? Oh, hell, another hour of algebra, sine, cos, and tan. Right. Non-90 degree triangles, we know we have to use the sine rule or the cos rule. Or the area rule if the area is given. If they ask you to find the area for non-90 degree triangles, you use the area rule. Or if they give you the area and you need to find a side or an angle, obviously use the area rule. You just make the side or the angle the subject of the formula. Hang in there, we're going for break just now. Let me just give you the whole overview. We're going to come back from break and then we're going to start cracking identities, reduction, special angles, general solution, non-90 degree triangles. On different planes. Right. So the first thing we need to know under trigonometry, we need to know reduction. How to reduce using your special angles. And what are your special angles? Your 30-degree, 45-degree, and 60-degree angles. Please learn them. Right. And after reduction, we need to know identities. And that you need to prove. And this you need to simplify. Then we need to know equations and general solution. And there the question will say solve for x. So it's very easy. The question already tells you what to do. If the question tells you prove, it's an identity. If it tells you simplify, it's a reduction. If it tells you solve or give the general solution, it's solving. Then we have trig substitution. By drawing the Cartesian plane and a triangle. If the question says, if sine 21 equals p, find cos 21 in terms of p. You've seen this before. So we need to know how to simplify. We need to know identities. You're going to get one of each in your paper. Only one. And that's going to make up your entire trig. So you need to know every single topic here. So please make sure you know these topics. So topic 1, 2, 3, 4, 5, 6. And there we go. That's going to give you about 40 marks in your paper. Okay? Let's start with identities. Come, before break. We've still got about 10 or 12 minutes, so it's nice we can finish it up now before break. Let's do identities first. Now I'm going to show you a lekker way, a kwai way of doing identities. We're going for break, guys. We're going to do identities and we're going for break. Here we go, here we go, here we go. Onliners, how are we doing there? Maths is mathsing, brabiza. Maths is mathsing today. We are moving on fantastic time. Nothing better than a cup of kusista in the morning, for breaky. Right, let's go, let's go, let's go. We're starting with identities. Pay attention. So, guys, again, by tonight, all this year is loaded up onto YouTube. So if you forgot something, you'll go back. You'll go back. Watch it over and over and over until you understand. Even if you missed out yesterday's session, go to the Awqaf website, awqafsa.org. Let me just put it up again. Awqaf. Am I spelling it right, Hassanin? A-W-Q-A-F. 1A.
It's on the screen at the moment.
Oh, it's on the screen. I don't see the screen there. I'm actually on the Jamboard.
It's A-W-Q.
There we go. www.awqafsa.org.za. Thank you, guys. I forget I got a back-end team,
Here we go.
Right, here goes. Right, guys. The website is on there. But for our online learners here, for our on-siters as well, there's it. Awqaf, A-W-Q-A-F-S-A. www.awqafsa.org.za. You'll watch yesterday's and today's. Right, here goes. Check here with identities. Now listen to me, man. Identities come from the word identical. So if you have a pair of twins, identical twins, and say this desk where I'm sitting is the equal to sign. So I bring 2 soldiers, right? Because we are a battalion, we are an army, so I bring two soldiers. twins. They are identical in every aspect, head to toe. On the one side of my table, I have the one brother who's fully kitted out. I'm talking, he's got boots, he's got the cargo pants, he's got the weapon, he's got the backpack. He is fully loaded, ready for war. On the other side of the table, I got his brother who's parking in his boxer shorts, in his simplest form. I'm being good. I'm keeping it age restricted. Now come on, guys. What common sense tells you? I need to prove them to be the same. Am I going to dress him up to look like him? Or will I rather say, hey, brah, undress. Get into your boxes. We need to see whether you're the same. Okay, those visuals are a bit bad. Yeah, but anyway. Obviously, we're going to tell him, take off your, undress. Now, how do we undress? What are weapons? What is loaded in trigonometry? Why am I using this? Brackets, surd signs, all of that is baggage. We need to remove the baggage to get him in his simplest form. And what is boxer shorts in trigs? Sine and cos. Not Tommy Hilfiger and Calvin Klein. Sine and cos. Sine and cos is its simplest form. So get into sine and cos. We tell both of them, get into sine and cos, and we're going to prove that the two of you are twins. So, hear me out. Hear me out. So now you say, okay, I understand what to do. How do I do it? So I teach you something lekker. Pay attention. We use Ali. It's done in 2 steps. Ali does identities. Now, who is Ali? AL. Step number 1, you do your AL for algebra. After you finish with your algebra complete, now you look for your identity. And then left-hand side will equal to right-hand side. I'm going to show you just now. Now, so Ali does identities. Ali does identities. Right. What are our identities? We all know sine squared theta plus cos squared theta is equal to 1. So sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. We all know that. And we also know 1 minus sine squared is a difference of 2 squares, and 1 minus cos squared in algebra is also a difference of 2 squares. We all know that. We also know that tan squared theta is equal to sine squared theta over cos squared theta. So these are our identities. So step number one, we do algebra by removing brackets and simplifying. And we want to simplify everything in terms of what? Sine and cos. That's all. And then we look for our identity. And where's our identities? There. Once we do that, we've proven left-hand side is equal to right-hand side. So let me give you an example. Prove. Check this out. Prove that sine theta plus cos theta all squared is equal to 1 plus 2 sine theta cos theta. For 3 marks. That's your question. Here's your answer. Right. Who does identities, guys? Grade 11. Who does identities? Ali does identities. So let's do step number 1. Which side of the equal to sign has got baggage? Left-hand side, because he's got brackets and he's got a square. So let's do the algebra. In algebra, left-hand side is sine theta plus cos theta all squared. Let's do the algebra, guys. Let's do the algebra. Forget about trigonometry. Let's do the algebra. This is equal to sine theta plus cos theta into, because it's squared, into sine theta plus cos theta. We're not yet done with the algebra. Let's finish the algebra. So we're foiling it out. First, outer, inner, last. Yes or no in algebra? Sine times sine is what? Sine squared theta. That's my two first terms. My two outer terms, plus sine theta cos theta. My two inner terms, plus sine theta cos theta. My two last terms, plus cos squared theta. We're not yet done with the algebra. Sine squared theta. 1 sine theta cos theta plus another 1 sine theta cos theta. 1 cell phone plus 1 cell phone. 2 cell phones. I'm done with my algebra. From Ali, I'm done with AL. What do I look for now? I can't hear you. And where's my identity? Isn't sine squared plus cos squared 1? So this is equal to 1 plus 2 sine theta cos theta. And isn't that my right-hand side? Therefore, left-hand side is equal to right-hand side. Bada bing. Got it? Let's pick up the pace. I'm going to give you 3 or 4 examples, and we're going to be using this is like the easiest one. This is cheese, man. This is chips. This one was chips. Let's pick it up. Let's pick up the pace. Come on, give us a bigger battle. Don't give us Conor McGregor. Give us Alexander Volkov. I'm going to smash your boy. I'm going to kill everybody. You guys don't know Islam Makhachev. Ish. Hamzat. Can I erase? Let's go. Well, I'm Team Khabib. I'm Team Khabib. Right. Team Conor, we meet you outside. Prove. One of the questions that came out, very popular question, 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equal to 2 over cos squared theta for 4 marks. Prove. Question, answer. How are we doing it? Robert. Big shout out there to Robert. Hello, Robert. Mike, we'll check today. If we got enough time, we'll do finance and probability. I will try my best, depending on time. Remember, we're finishing the whole year's syllabus in 2 days. We had a bit of a delay yesterday of 45 minutes, and that cut into our program badly. But we're there. Rory Sang, the winner of our past maths competition, will be joining us during break.
That's
yes.
correct.
The learner who got 100%. You want a bigger battle? My sister, Khomozo, don't worry. The bigger one is coming now. Right, let's start on the left-hand side. Left-hand side, let's do the algebra. So what the left-hand side is that. So let's go. Let's do it together, guys. Let's do the algebra. 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equal to, we are adding 2 fractions. So we're going to do the lowest common denominator, LCD. So that's going to be 1 plus sine theta into 1 minus sine theta. Now, we divide. Whatever is left over, we multiply. So 1 plus will cancel. I'm left with 1 minus sine theta times 1 is 1 minus sine theta. Guys, please don't ask me what I'm doing. This is the lowest common denominator. I'm adding 2 fractions. Now, 1 minus will divide into this, that, and that will cancel. I'm left with 1 plus. 1 plus times 1 is 1 plus sine theta. So there we go. That's the LCD. That's the shortest, best way to do the LCD. You multiply the two denominators. You take the old denominator, you divide it. Whatever is left over, you multiply it back by your numerator. Right. So let's go. Minus sine theta plus sine theta is 0. 1 plus 1 is 2. You're so clever. All over. The denominator in algebra is a difference of two squares. So 1 times 1 is 1. Positive times negative is negative. Sine times sine is sine squared. Now we look for, what do we look for? Identity. 1 minus sine squared is what? Cos squared. So it's 2 over cos squared theta. Therefore, left-hand side is equal to right-hand side. Here we go. We are done. Okay. Let's see the one that came out in the past paper. And let's end up with that one. Let's end up with that identity. Before break, there were some formalities this morning for 5 minutes. So guys, you can blom for 5 minutes. Take a chill pill. Right, here we go. Last one, the one straight out of a past paper. Straight out of a past paper. I hope you guys got this one out. Big shout out to Mike. We won't say your surname. Right, prove that sine theta minus tan theta times cos squared theta all over cos theta minus 1 plus sine squared theta is equal to tan theta for 4 marks. Proof. Now, I haven't done this one before. We're all going to be doing this one together for the first time. Take this one down. This is the last one before break.
1, 2. Rory Sang in the house. Can we get a round of applause, ladies and gentlemen? Rory,
Hey. Rory Sang.
Rory. Yes,
Welcome,
please,
welcome,
Mr.
welcome,
Khota.
welcome, welcome, welcome.
Okay, Rory
Have a
Sang,
seat.
join me over here. We'll have a discussion. Mr. Khota has 5 minutes left. Have a
Yeah,
seat.
I got 5 minutes left. The two of you can jab away
Have a
there.
seat, sir.
How are you, Rory Sang? I finally get to meet you in person. I'm great. Okay, guys, let's do this. Left-hand side. This is Rory Sang that just walked into the house. The guy who got 100% last year in mathematics. 100%. Yo, not 99. You know what is 100? Total. Right, let's go. So left-hand side, so we got sine theta. We can't do anything with that. Tan theta is what? Sine theta over cos theta. We want to convert everything to sine and cos. Times cos squared theta. I'm going to break it up into cos theta over 1 times cos theta over 1. That's sine theta over 1. Right? I'm just breaking the cos squared up into cos times cos. All over. Cos theta minus 1 plus, what do we want to do here? Sine squared theta. Let's just leave the sine squared theta. Let's see what can we do here. Let's see where we're going with this. At this point in time, I don't know where I'm going. I'm just converting everything to sine and cos in terms of my algebra. Right, so we got sine theta over 1 minus cos theta and cos theta will cancel. So I got sine theta cos theta. All over. Something tells me to break this one up. So cos theta minus 1 plus sine squared is 1 minus cos squared. There's an identity there. Now here on the top, Rory, I know Rory Sang is looking at this, he's saying, Chips, man. Knickknacks. Zimba chips. Right, that's minus. Highest common factor, sine theta. We left with 1 minus cos theta. In algebra, we pulled out the highest common factor. This was an identity. All over. Let's remove the brackets. Cos theta minus 1 plus 1 minus cos squared theta. I'm going to move over to the side because I don't have space. So sine theta into 1 minus cos theta. I'm not yet done with my algebra. This is all algebra. This is all algebra. Minus 1 plus 1 cancels out. Cos theta minus cos squared theta. I'm going to take out the highest common factor there again. Cos theta. And guess what I'm left with? 1 minus cos theta. Bada bing, bada boom. That and that cancels out. Sine theta over cos theta is equal to what? Tan theta. Therefore, left-hand side is equal to right-hand side. And we are done with this problem. A problem like this can be worth 4 to 6 marks in your final exams. Boys and girls, I think let's give a nice round of applause to Rory Sang here for coming and gracing us here. And I think let's give Rory Sang about 2 to 3 minutes before our break. So just to give our learners a few words of encouragement. So Rory Sang, take it away before we go for break.
Thank you so much. Good morning. I'm sorry for my voice. Like many people last night, I was screaming with joy after the Springboks won. So you'll have to forgive me on that one. Um, I'm very excited to see this number of people at school on a Sunday. This is very exciting. You're setting yourselves up for success in your exams, which will like enable you to get great marks and enable you to get into university. So I'm very impressed. Please give yourselves a round of applause for being here on a Sunday. And I know I don't have a lot of time, but I just wanted to say this. Um, I am from Pumalanga, a very small school in Pumalanga. There was nothing very glamorous about my life, but I still managed to get great marks and get into the degree of my choice. I am now doing actuarial science at UCT. So I want to tell you that. Should I get up on the stage? Oh, okay. I just wanted to tell you that no matter where you are from, no matter what kind of situation you come from, whether you have you're well off at home, you're not very well off at home, you can still realize your dreams. That's really all I have to tell you because by the fact that you are here on a Sunday really means that you're determined and you have the motivation to do it. So keep up the good work and very good job. And thank you to Mr. Khota for being here. Thank you so much.
Okay, so Rory, sir.
Thank you so much. Thank you so much. Thank you so
I've got
much.
one question there for Rory Sang while we are still here. Just let the grade 11 learners know how important this year is as part of a gateway to their future, as part of their future career paths.
Yeah, grade 11 is very crucial. You may do well in your final exams in metric, but like you use these results to apply for university. And they don't really compromise on that. They really need your grade 11 results. So by working hard, you'll enable yourself to get in university. It's a very crucial year.
Okay, thank you so much. So, Mr. Khota, we will break now.
Yes, we'll go for break. We'll go for break. We'll go for break. Guys, it is 22:11. We'll give you break. We will commence at 11:15. 11:15. We commence. We resume at 11:15, guys. We resume. Enjoy your break. Enjoy your break. Enjoy your break. Onliners, see you at 11:15.
So, Mr. Khota, while we are having our break, Mr. Khota will join us for a discussion here with Rory Sang, and we'll speak to Rory Sang to find out um, what has been like during the maths workshop. So we'll now have a discussion, and we will continue our discussion with Rory Sang. Mr. Khota, if you can join us over here. So we are coming to you live from the South Peninsula High School. We just completed the first quarter of the grade 11 maths workshop. We're coming to you live from the South Peninsula High School here. Yesterday we did the Awqaf SA maths workshop. We focused on maths paper 1. Today it is maths paper 2. And we do have Rory Sang with us today. Rory Sang is going to share some more information about the competition that OCAP is currently hosting. So to all participants that have participated in our workshop, we are going to be hosting a competition and it will open up in January 2024. Rory Sang did participate in this competition, so you'll share some more information about how learners can participate in this competition, and you'll also let us know how the competition and maybe the prize money has assisted it. Rory Sang, share some more information.
Thank you so much. Thank you. I don't think this is on. Is it on?
Can we power this mic on, please? Okay, let's see. Do we have it in?
Oh, it's on
There
now.
we go. So
Thank you so much. I mean, by virtue of just registering for the workshops, you're in the competition. I'd say you just have to register. You will get an email in January when your results are released to submit your June results and your final exam results, your statement of results, and from then on they will process it. And in about, was it 3 weeks or
3 weeks.
yes, you will be contacted if you are one of the winners. And the prize money has helped me quite a lot.
How did it help
It
you,
helped me
Rory-san?
contribute to buying a tablet, which I now use for my notes and like working, because I'm studying an actuarial science degree. I do a lot of math and stats, so I need a lot of paper. So I just decided to save the environment and get a tablet instead.
So some of that hard cash actually assisted you in terms of your preparation for your first year of study at university.
Yes, it actually did.
So
It
there we go.
definitely
How's
did.
that for an incentive? When you first found out about this competition, how did it motivate you?
Well, for me, my final results were more about making myself proud, but like I'd say the competition definitely motivated me as well, because there's always an incentive in knowing that you might get a prize for doing well in your exams. So that definitely, in addition to me wanting to do well, the competition helped me do well.
Okay, so looking back in terms of a participant of the workshop, how did the workshop, what was it about the workshop that really assisted you, as compared to maybe a conventional workshop or a classroom session that you had? Just reflect on that.
Like I said, I think I said this when I was first interviewed in February. I like how Mr. Kota just improvises with maths. Like how there's no recipe to do in maths. I know some people might disagree, but like if you just go in with a clear head and knowing your principles, you can definitely do anything. Like he was doing this last problem here, he was like, oh, let's just leave this for now and we'll see it later. That's really what I liked. He wasn't forcing us to have hardcore recipes for solving math problems. You just needed to know your identities, your principles, and then you'll fare by, you'll do very well. So I really like that.
Okay, so now I'm going to turn to Mr. Khota. Mr. Khota is the facilitator of the session. He's been the driving force in some of the magic of the session. So, Mr. Khota, just share with us that, Rorisang means so much to our learners. Our country we are so fragmented and so divided, and we've got so much challenges stacked against us. Lots of our learners are suffering as a result of some of these challenges. The list goes on. No access to internet, overcrowded classrooms, load shedding. The list just goes on. Just share with us, through workshop in, workshop out during the course of the year, how you've been using some of the success of Rory. And Rory Sang has actually become sort of a beacon of hope and ambassador of the project. Just share some of the sentiments there, Mr. Khota.
Rory-san, just to tell you, let's see, here we go. Right, Rory-san, just to tell you, congratulations once again. We finally get to meet. We were online the entire year last year, and now we get to meet each other in the flesh, as they say. So congratulations once again, and it was an absolute pleasure contributing towards that prize money that was also helping you this year. Boys and girls, Rory Sang has also become not just a beacon of hope, he's been added. You've become iconic. He's become iconic, just like the Bucker who won last night. You've become a beacon of hope, because the Bucker showed us last night, our Springbok rugby team winning the World Cup last night, showed us that through a divided nation, how sport can bring us together, an immaterial of race, color, or creed. Working together, we're always going to hold up the trophy. And the same thing you showed us last year, that it doesn't matter where you're from. Western Cape always boasted about the best results. You showed us that a guy from Mpumalanga can show us flames. Show Western.
Limpopo, Mr.
Limpopo.
Khota, please.
Mpumalanga.
Okay,
Right. From Mpumalanga, that we can show South Africa flames. So it doesn't matter where you guys are from, whether you're from any of the 9 provinces, we are all one united country. We're not a divided country. We do not care whether you are black, white, colored, or Indian. Math is math. You are now, where the Bucker showed us diversity in sport, you are showing us diversity in education. And we need this. We need you, the learner of South Africa, from all different colors, to come up, show us. We want to stand here in front next year with a full diverse panel of 100%ers from the colored community, from the Indian community, from the white community, from the black community. Show us your skill, and let's put South Africa back on the map. So once again, thanks for attending all the workshops. Thanks for showing us that you've gained so much from the workshops. And yeah, good luck.
So speak to us there, Rorisang. You're here at South Peninsula. You've got a cohort of very determined learners. Just tell us how you're feeling to be in person with us finally, with Khota and myself. It is an amazing feeling to be with you in person. So just share some of your sentiments.
I'm very excited. Just seeing learners in a school on a Sunday, that does it for me. It seals the deal for me. So it just made my heart so excited to see a hall full of learners on a Sunday, and it's very exciting to see you two in person, because we've been online for the most part of this year actually, and last year as well. So it is very exciting.
There we go. So that was our discussion there. Any concluding remarks, Mr. Khota? So what I want to do now is I want us to go and spend some time with the learners, go and take some happy snaps over there, give them an opportunity to spend some time with Rory Sang. Any concluding remarks before we head
We
off?
know we've got a cohort of parents, learners, teachers that are watching this now online from all over the country. We've got 10,000 online participants today. Last year also, I think we had close to about 200,000 to 300,000 eyeballs on screen in our final workshop in grade 12 last year. And thank you all for being part of the show. Hope you guys are enjoying the Sunday morning with us doing mathematics. It's not every day that somebody puts on the TV and says, I'm going to sit down today and watch math. And even through our live shows on Hilal TV during the week, we had parents that called in and said, you know what, we love it. Parents that said, we're watching the show. We didn't know what the show was all about. Now we hooked. We're loving the show. And thank you all just for engaging into this initiative. So, yeah, that's it from me.
Yeah, so that's it. Kudos to Mr. Khota also. And, from Awqaf side and working with Mr. Khota, I think he's got some key ingredients for us to gamify maths, bring that excitement, that high energy in mathematics. So that's it. We will resume at 11 o'clock. This is the grade 11 maths workshop, maths paper 2.
One, two. One, two. One. You see it's feedbacking. Go to each speaker quickly and then check. Go to each speaker. One, two. One. One, two. 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 1, 2, 1, 2, 1, 2, 1, 2. Testing 1, 2.
Welcome back, learners. Welcome back. We're gonna come in shortly in the next 5 minutes.
Students, could we please be seated? Thank you.
Welcome back to the grade 11 maths workshop. We are dealing with maths paper 2 today, and we're just having a discussion with Rory Sang, the winner of our past competition. He was part of the grade 12 workshop. So before we commence, we'll just bring on Mr. Baker. Mr. Baker is the principal of South Peninsula High School. We're coming to you live from Cape Town, and you'll also be having just a very brief conversation with Rory Sang. Mr. Baker has been inviting some of the other schools here in the Western Cape, including schools from Spine Road as well as Livingston. So we hand the mic over to Mr. Baker, and also just have a few words about Rory Sang and what his achievement means to some of the learners that is present here today. Mr. Baker?
Thank you, Asnain. It is it's wonderful to have Rory Sang with us. He's all the way from Mpumalanga, and I'm sure that he has been welcomed. He's currently doing an actuarial sciences degree at the University of Cape Town. He's obviously been headhunted by the University of Cape Town, and I'm sure he also has a bursary, and that comes through hard work. Students, if ever you ask me, been in teaching for 36 years, what is the recipe? What is the recipe for achieving in matric? It's a simple philosophy and simple answer to that question. And the Rory Sang bears testimony to that. And that is, students, we need commitment, we need resilience, and it comes down to hard work. And I want to say this to you, students, that often amongst your peers, you may find those who are cool, those who don't really have a plan in place, and sometimes they get the results. But I would say that more than 80% of students who achieve, 90% of students who achieve, are students who have that plan in place and are prepared to make the sacrifices and are working hard. And, this workshop that we're having for maths, this workshop for me is not only about you performing in maths paper 1 and paper 2. It's also about getting you to, or we're planting the seed for you to understand what matric is about. Matric is about those sacrifices that you need to be making, especially over weekends. And yes, we do understand that some of you are also trying to earn some income. Some of you are also trying to support your parents. So you may have a casual job over the weekend. My advice to you is, yes, you've got that casual job. You need to work around that casual job. And for me, a matric student, especially over weekends, at least 6 to 8 hours of work. You must always be on top of it. Always be ahead of the teacher. And that doesn't only apply to maths, but it applies to other subjects also. I'm handing over to Rory Sang.
Thank you so much. You have really said it all. It's very true, and I cannot emphasize the importance of staying ahead of the teacher. Well, we're not saying that teach yourself the material. Just go into the classroom having an idea of what you're going to learn about the next day. So that's thank you so much. You have really said it all, and thank you, Mr. Khota. Thank you, Hasanain, for inviting me here. and I really wish you all the best for your final exams. And I'm hoping to see you, some of you or all of you, here in stage in 2025, speaking about your experience in metric. Thank you so much.
So thank you. That was Rory-san. And Rory-san is one of the ambassadors of this program because some of his success is our success. And you can also do the same as Rory-san. Rory-san is very determined, very disciplined, and very dedicated. And you will be in grade 12 next year. And God willing, Rory-san will be with us, sharing some more progress as he goes along. And Rory-san also has put it to you that when you become a success, you're also going to have to empower other learners. And this is how we make South Africa great again. Just a concluding remark from Mr. Baker before we hand over to Mr. Khota. He's ready to blast off into space.
Yes, if I could just use the opportunity to firstly commend the teachers of the schools who are present here today. We have the maths teachers of Spine Road, the maths teachers of Livingston, the maths teachers of Islamia. See, there's a student from Islamia also, and then obviously the maths teachers of the whole school, South Peninsula High School. Thank you for the work that you are doing, and it is wonderful to see a room filled with so many pure maths students. I want to say, students, you are a privileged group of students because we find that unfortunately a lot of our students at our schools in grade 10 and grade 11, they are doing mathematical literacy. So they are not being exposed to the presentations that you are getting, that you got yesterday and that you are getting today. And let me tell you this, students, maths is teaching you one very important skill, and that's problem solving. And that is a skill that you require for any profession. And so those students who unfortunately are not pure math students, they lose out in terms of that. Thank you very much, Hasnain, to Awqaf, and thank you very much, Mr. Khota.
Thank you, thank you, thank you.
Take the show away. Thank you.
Thank you, Hasnain. Thank you, Mr. Baker from South Peninsula. Always great to be here in Cape Town, the mother city. Remember, we are all one. Last night, like I said, the Bokke showed us that united we stand, divided we fall. Guys, welcome back, welcome back, welcome back. I hope you guys enjoyed your break. Onliners and our 10,000 logins, students, online learners from across the country. We've got a full house at South Peninsula in Plumstead, Western Cape. And yeah, we'll be seeing KZN very soon and Gauteng for our grade 10 workshop next week. We'll be beaming and broadcasting from the Roshni Islamic School next week, Sunday, for grade 10s. Right, we're starting with reduction. Reduction is our special angles. Now, if you guys pay careful attention to what I'm about to tell you now for reduction, I promise you, you're going to have no problems with reduction from now till grade 12. Now, many of you have got a whole stack of notes. I want you to put that aside. I'm going to give you one template here on the screen now. If you learn this, I promise you, I'm doing the shortened study notes for you. How did I get 100% in matric from getting 20% in June of that year? I'm sharing with you my own study notes. This is what I did in order to get 100%. Like Rory Sang, who got 100% last year. I clocked mathematics in grade 12 using the very notes that I'm showing you now. So I'm going to summarize everything for you on the screen. Everything you need to know about reduction. So I call it, in my own terms, the 5-block rule. So, and I'll show you when we start applying the 5-block rule, how we're going to get full marks for this topic. The first block is what I call, when we talk about the Cartesian plane. Right. So let's make block number 1. There we go. Now, if you have an angle, example, if you had an angle, let's say 225 degrees. Do I say 270 minus or do I say 180 plus? Why? So that means in the Cartesian plane, if an angle lies here, it's 0 degrees plus. Don't say 90 minus. It can be 90 minus also, but you're going to use 0 plus. That's 0, that's 90, that's 180, that's 270. If an angle lies here, we're going to try our best to use 180 minus. If an angle lies here, we're going to use 180 plus. If an angle lies in our fourth quadrant, we're going to use 360 minus. And we're going to avoid using. So the vertical line, the 90 degree plus or minus and the 270 degree plus or minus, we're going to avoid using it. I'm not saying never use it. Avoid using it. Why? Because the name changes. And the name changes to its co-function. So sine will change to cos or cos will change to sine. The 180 degree plus or minus or the 360 minus, the horizontal line we use. Why? Because the name stays. And that is our first block. The second block, pay attention. Pay attention. That was block 1. Here's block. Block 2 is what we call the negative angle. It's going to be tested. 100% it's going to be tested. So you need to know what to do with the negative angle. So sine of a negative angle is minus sine of that angle, to remove the brackets. Tan of a negative angle is minus cos of a negative angle is equal to, so I'm going to put a star there. Cos of a negative angle is positive cos of that angle. It doesn't become negative cos of that angle. Why? A negative angle does not exist in a world of cos. A negative angle, 0 plus, remember that's 0 plus, 0 minus. 0 plus, cos is positive. 0 minus for the negative angle, cos is also positive in the fourth quadrant. You guys all know ASTC, the cast diagram. All positive, sine positive, everything negative. Quadrant 3, tan positive, everything else negative. Quadrant 4, cos positive, everything else negative. So cos is positive in your first and your fourth. That is why a negative angle does not exist in the world of cos. The third block that we have is what we call the anti-clockwise angle. Anti-clockwise angle. Right? So that is like sine, let's say x minus 180. Now, how do we sort this out? Now, normally you have 180 minus x plus 180 is not an anti-clockwise angle. X minus, because x plus 180 is the same as saying 180 plus x. That's not anti-clockwise. But x minus 180 is anti-clockwise. I'm going to show you a trick. How to sort this out. You do what I call the dial method. Watch here. This is your trick on the side. This is your shortcut. Sine 180, we know 180, the name stays sine x. The name doesn't change. If it was 90 or 270, the name would change. So we leave it as sine x. Where is sine? Sine is positive. Sine is in your second quadrant, yes or no? We need to move 180 degrees anti-clockwise. So watch here. From here to here is 90. From there to there is 180. That means it moves, sine moves from there to this quadrant here, 180 degrees. What is sine in this quadrant? Positive or negative? And that's your answer. So you just use the dial method and then you check in the quadrant whether it's positive or negative. Let's do another example. What if I told you cos x minus 270? Now cos 270 will change to sine x, because 270 changes the name. And let's use the dial method. Where is cos? In your fourth quadrant. We're going to move 270 degrees anti-clockwise. Let's do it together. From there to there is 90. From there to there is 180. From there to there is 270. What is cos in this quadrant? Positive or negative? And that's how you sort it out. Are you all okay with that? Take these 3 blocks down. I'm going to do 2 more blocks. So you have to use the Cartesian plane. You will get negative angles. You will get anti-clockwise angles. And in fact, I'm going to show it to you just now when we start doing past paper questions. So these are our 5 block rules for reduction. You master this. Whatever other notes you have with reduction, use it as toilet paper. Put it aside, tear it up, burn it. You don't need it. This is all you need. I'm giving you all the tools you need on one screen. All you have to do is learn the screen, memorize the screen. You'll see it. No matter what we're given, the minute we use the tools from the screen, we're going to get full marks all the time. And you're going to get 2 questions like this in your exam. One where you're going to reduce angles, or one where you're going to use special angles. And you're going to use all of this. So this is your toolkit. How are we doing there, onliners? Are we on fire? I hope you're paying attention. Check your network connections, guys. Check your network connections. Come on, onliners, take this down. Block 1, block 2. Let's make a block around this. This is block 3, your anti-clockwise angle. So block 1, your Cartesian plane. Block 2, your negative angles. Block 3, your anti-clockwise angles. There's 2 more. There's the square angle. Sine squared. What do you do with a square? And then there's an angle greater than 360. What do we do with an angle greater than 360? When we're done with this, then we are ready to tackle the ones from the question. If you don't know this, you're going to get it wrong. You're not even going to know where to start. Your starting point is this. These are your rules. Anything in math, know the block of rules. Once you know your set of rules, you can play around with the rules to get to your answer. If you don't know the rules, don't even try it. You're going to get it wrong. Like we said yesterday, you're going to fail nicely. Got it down, guys? Got it down? So 1, 2, 3. Right, let's do block number 4. We're doing block 4 and block 5. Then we're done. Let's do block 4 and block 5. For those of you who have taken it down already, I'm just putting it here on the top. Block number 4. Block number 4 is your square angles. Anything squared is always positive. So if I told you sine squared 270 minus x. Pay attention. Let's do it. What do we do when we see this in a problem? Sine 270 will change to cos squared x. Do I need to check in which quadrant is it? Is it positive or negative? No. Because anything squared is always positive. Are you guys following me? Paying attention? But be careful, they can try and trick you. They can tell you minus sine squared. 180 plus x. Be careful here. Watch here. Sine 180 will remain sine squared x. Now this here is positive. That is positive. And a positive times a negative is a negative. Be careful. That's a trap. It's a trap. Don't fall into the trap. So anything squared is always positive. Now we're doing the last block. An angle greater than 360 degrees. So let's go. Let's take that out. An angle greater than 360. Example. Cos 480. Now, you know a circle is only 360 degrees. So the first thing you do from any angle greater than 360, you minus 360. Right. So this would become cos 480 minus 360 is how much? 120. Now let's all do it together. 120 special angles. Am I going to say 90 plus 30 or am I going to say 180 minus 60? Good. So we're going to say cos 180 minus 60. Now cos 180 will remain cos 60. Your quadrant falls away. And 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. And that is cos 60 is a half. Step by step. So even if you had an angle like 750. What if you had, I'm going to do another example, one quick one for you on the side. Say you had sine 750. So that would be sine. How many 360s are there in 750? 2. 2 times 360 is 720. So you're going to say 2 times 360. You'll count that as 360 degrees. Plus 750 minus 720 is how much? 30 degrees. Sine 360 will remain sine 30. 360 plus is in your first quadrant. 360 plus, sine is positive. Sine 30 is a half. Okay. And there we go. So this is block number 4. And that is block number 5. So this is our 5-block rule for reduction. Now let's have fun. Let's take a past paper, 2 questions. Listen to me. Here's the fun part now. The fun is the application. Because we want to test whether these 5-block rules work. 2 questions, one for 6 marks, one for 6 marks, 12 marks for reduction. Let's check. Let's see what's the question. I'm taking out of a past paper. Okay, here goes. 6 marks. And you're going to smile. You know why? You're going to see a lot of these 5 blocks in the question. Not all. You'll see a lot. So we got that. Onliners, are you ready? Take a deep breath. Are you ready for the 2 questions? Guys, are you all right there? Onliners, are you okay? Onliners, are you all right? Give us a thumbs up. Hit us up in the comments. Working now?
1, 2.
Check your internet connection from wherever you are, guys. If you guys got a poor network.
1, 2.
Alles reg?
Alles reg by die huis?
Alles all right? Yes, let us know. Come on, talk to us, guys. Talk to us.
Mr. Khota.
Let's go, let's go, let's go, let's go, let's go.
We have Tahia. Tahia is with us. She's in the background.
Okay.
Later on, she will emerge. So who Tahia is a host. She's logging on from the Awqaf SA Johannesburg studio. She's going to join us later on, but she's going to be flighting and doing lots of the back office. Being at Wits, but you'll see her or a little bit more of her later on during the day. So, Mr. Khota, give a shout out there to Tahia.
Welcome, 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 Tahia. Are you there? Are you in already? Is Tahia in? No?
She's there, but you'll show her face later on.
Okay, okay, okay. Welcome, Tahia. Welcome to the show.
Thank you so much for having me. I'm so excited.
King math. With Dalaing math. Right. That's your question. Simplify that. Now you can clearly see there's a 90 degree, there's a 180 degree, there's a tan which is sine over cos, and there's the anti-clockwise angle. So while we put it down, you guys can start. Let's see what you guys do with this. Come, choose each part on its own. Do that, do that, do that, sort that out, sort that out. Go for it, guys. Alles reg. Welcome those who have just joined us, our 10,000 learners online from across SA, Witbom High, Cape Town, Western Cape. Caitlin, welcome, welcome, welcome. Boynelo Shelton from Ratong Tuto Secondary School, welcome. Shoshanguve, Mr. Slope, welcome. Bridget, good morning, Bridget. Orange Farm, Gauteng. Welcome, welcome, welcome. Let's go. Right, sine 90. This is equal to, when they tell you simplify, you must put an equal to sign. Sine 90 will change to cos x. 90 minus is in my first quadrant. Sign is positive. Times cos 180, the name stays, cos x. 180 plus is in my third quadrant. Cos is negative. Plus tan x. What did I say? Convert it to sine over cos. Cos x will remain cos x. There's nothing we can do there. Times, sine 180 will remain sine x. It's the anti-clockwise angle. So we start there from sine. We move 190, 180. What is sine in this quadrant? Negative. There we go. Can you see how we use that anti-clockwise, that dial method to sort this out? This is equal to, a positive times a negative is a negative. Cos times cos is cos squared x. Cos x and cos x here will cancel because we're multiplying. A positive times a negative is a negative. Sin x times sin x is sin squared x. What do I notice here? I can pull out the negative. And now both these signs change. So I get sin squared x plus cos squared x. And what do I know? Sin squared plus cos squared is my identity. And what's my identity equal to? 1. And that's your final answer, -1, and you got yourself 6 marks. Are you with me, grade 11s? Can you see how quiet that 5-block rule works? Know your Cartesian plane. Know your negative angles. Know your anti-clockwise angles. Know your square angles. Know your angle greater than 360. You'll be able to crack any of these. Now, this was in terms of x. Let's give you one in terms of special angles. Let's do your special angles. Let's give you another one in terms of special angles. Onliners, how are we doing there? How are we doing there, guys? Talk to us. Hit us up in your comments. KZN, good morning. Priceless Boy, good morning. Robert, here's a big shout out. Robert wants a shout out. Diazville High School, Western Cape. Guguletu, well done. You got -1. Ethan Nemuru, Squinspruit Secondary School, Western Cape. Good morning, good morning, good morning. Mohammed Arif, hey, how are you, bro? Akisha Nacht. Katlejo, hello Katlejo. Grand. Our onliners are online, downloading at crazy speeds here. Let's see if you guys can crack the next one. It looks difficult, it's not. Honestly, it is absolutely not difficult. Simplify or prove without the use of a calculator that sine 135 times tan 210 times sine 190 all over cos 100 degrees times sine 120 degrees is equal to minus root 2 over 3 for 6 marks. So although they're saying prove, yes, it is an identity. But we're not using identities, we're using our special angles to prove that left-hand side is equal to right-hand side. Basically, they can ask you to simplify that to get this answer or to prove this to get this answer. It's the same thing. Do you guys want to try it on your own or you want me to do it for you? Remember, listen, let me help you along. 135, you've got to break it up into brackets. Special angle, 180 minus 45. 210, 180 plus 30. 190, 180 plus 10. But 10 is not a special angle, but it will be sorted out here. Here we're forced to use 90 plus 10. The 120 is 180 minus 60. When you simplify it all correctly, 100% you will get the right-hand side. So come learners, come our 10,000 learners across the country. Let's see how you guys crack this one and get full marks, 6 marks in your exam. And obviously you're going to say left-hand side. That's where you're going to start. We're going to start on our left. We're going to make sure that our left looks like our right. So beautiful to see 200 learners working on a Sunday. Yo. Beautiful. Every learner is working. What a lovely sight. Tandi, Eleanor, Sibeko Secondary School, Gauteng, Skolile, Mflengi. You're going to bang math. Come on, you guys' brains are in the gutters, man. Bontle, check your internet quality. We are boosting on 200 megabytes per second from where we're beaming. If your quality is bad, check your internet connection. HB Nyati Secondary School, Bushle, how's it? Chekofatso, Mabelo, Cultura High School, Caitlin Weavers, on fire. Hillcrest High School, KZN. Let's do it. You should be done by now. 3 minutes. 6 divided by 2 is equal to 3 minutes. Your time divided by 2, your mark divided by 2 equals your time. Sine 135 is sine 180 minus 45. Tan 120 is 180 minus 60. Sine 190, sine 180 plus 10. all over cos. Here I have to use 90 plus 10 because I want to get in at 10 degrees. So I'm forced to use 90. Remember I said avoid using it? I didn't say don't ever use it. Here we are forced to use it. Sine 120 is what? Sine 180 minus 60. Right, let's reduce. Sine 180, sine 45. 180 minus, by now you can picture it in your brain already. I don't need to draw that. 180 minus, yeah? 210, sorry. 180 plus 30, sorry. 210, 180 plus 30. Thank you so much for paying attention. 180 minus 45 is 135. 180 plus 30 is 210. 180 plus 10 is 190. 90 plus 10 is 100. 180 minus 60 is 120. Thank you so much. Just checking if you were paying attention, brah. 10, 180. That will give me 10, 30. 180 plus third quadrant. 10 is positive. Times sine 10. 180 plus is in my third quadrant. Sine is negative. All over. Cos 90 changes to sine 10. 90 plus is in my second quadrant. 90 plus is in my second quadrant. Cos in my second quadrant is negative. Don't look at the changed one. Look at the original. Look at the original. Don't look at the changed one. So cos 90 will change to sine 10. 90 plus is in my second quadrant. Cos in my second quadrant is negative, not sine. Many of you make this mistake in the exam. Times sine 180 will be sine 60. And 180 minus is in my second quadrant. Sine is positive. Now, because we're multiplying and dividing, let's sort out our signs first, positives and negatives. A negative divided by a negative is a positive, so our two negatives will fall away. By now, hopefully, you know your special angles. If you don't know it, cheat. Use your calculator. Right? As long as you give your answer in third form. So sine 45 is square root 2 over 2 or 1 over root 2. Tan 30 is root 3 over 3. Sine 10 and sine 10 will cancel. Divided by sine 60, which is root 3 over 2. Now, root 2 times root 3 is root 6 over 2 times 3 is 6. Divided by root 3 over 2. You can do this on the calculator also, or you can do it manually. You're definitely going to get that. So, root 6 over 6 times 2 over root 3. What are we left with? 2 goes into 2 once. 2 goes into 6 3 times. Root 6 divided by root 3 is root 2. So, we got root 2 over 3. Hey, where did the other negative come from? Where did that negative come from? Let's check the question again. Let's double check. 180 minus 45 is sine 45. 180 plus 30 is in my third quadrant. 10 is positive. That's correct. 180 plus is in my third quadrant. Sine is negative. Cos 90 will change to sine 10. That's negative. Sine 180 minus 60 is sine 60. Negative divided by negative is a positive. There isn't another negative sign here. There's a problem in the question paper, brah. 180 minus is in your second quadrant. What is sine in your second quadrant? Thank you. So there's a problem in the paper. You see, when you know your work, you can pick up a problem from the question paper. There's no negative here. That means your answer has got to be positive root 2 over 3. There's no other negative here. I don't think I'm right. I know I'm right. There's no other way. 180 minus 45. 180 plus 30. And 180 plus is here. 10 is positive. Sine 180. We got maths teachers here. Ma'am, you want to check this one out? Check if we're losing a negative sign here. I don't think so. 180 plus is there. That's negative. That's correct. Cos 90, that's negative. That's correct. Sine 180 minus 60, that's correct. Negative divide by negative, the whole thing is positive. So there's no negative sign in the problem. Okay, so there we go, guys. Right, now I'm going to show you a different style. Now we're going to do what we call trig substitution. So we're done with reduction. Put the heading trig substitution. Onliners, Ratang Tuto High School, Petite High School, Munir Samsudin. Welcome, welcome, welcome. Hope you guys are enjoying the show. Ethan, I'm clearing here. I'm clearing here. I hope you've taken it down. Here we go. Right, we're doing trig substitution. If sine 21 equals P. They can use P, or they can use K, or they can use M. Fine. Question number 1. Cos 21. Let's see. Sine 201. Two sine 21 over tan 21 in terms of P. Right. 2 marks, 2 marks, 3 marks. 3 and 2 is 5, 7 marks on that. Okay. Mr. Slope, how's your internet quality there, brah? Check your internet quality. Remember, guys, if your internet quality is a bit bad, remember this is being streamed and it is on the Awqaf SA website. So you can even check it after the workshop. You can go through the entire workshop all over again. Right, now, listen to me. Whenever you see a scenario like this, watch here. Shh, put your pens down. I show you a lacquer way of doing. So we did Ali does identities, remember? So I give you a new acronym for this. SCRAP. Scrap. Right, so you scrap it. What does scrap stand for? The first S. This is a mental process, guys. Watch here. The first S. You got to put this into standard form, which it is not at the moment. And you got to use SOHCAHTOA. So SSS, SOHCAHTOA. The C, draw your Cartesian plane. R, look at your restriction. Let's give you a restriction. Here, no restriction. And P is greater than 90 but less than 360. Right, so look at your restriction. A, don't worry about A. A just means and. And P, use Pythagoras to complete it. So what do? Scrap. Let's do it. Let's follow this process. Check how lekker is it. So you got sine 21 is equal to P over 1. That's standard form. And your right-hand side must be a fraction. Standard form. So standard form. SOHCAHTOA. Sine is opposite over hypotenuse. Cartesian plane. Let's draw the so we're done with S. Let's do C. Let's draw our Cartesian plane. There we go. Now we're done with that. Done with that. R, your restriction. Greater than 90. So it could be there, or there. Greater than 90, less than 360. But where is sine positive? Where is sine positive? Only in your second quadrant. Yes or no? So wherever you got 2 ticks, that's where you draw your triangle. And that's 21 degrees. That's called your reference angle. And now opposite over hypotenuse, P over 1. And we use Pythagoras to finish it. We want X. So let's use Pythagoras to finish it. Come on. Let's use Pythag. So we're going to say 1 squared is equal to X squared plus P squared. I'm using Pythagoras. So 1 minus P squared is equal to X squared. X is equal to plus or minus the square root of 1 minus P squared. It's to the left of 0. So can it be positive? No. So what is X? Negative. X is minus the square root of 1 minus P squared. You have to draw the triangle. Guys, you have to use this method, scrap. You scrap it. Sorry? No, and. It's just and. Don't worry about A. A just means and. Standard form, SOHCAHTOA, Cartesian plane, restriction, and Pythagoras. So we scrap it. If you remember scrap, you can do, anytime you need to construct a triangle, you use scrap. These are my own acronyms. These are my own shortened notes, mental notes that I'm sharing with you. So when you see a person, you give a person a problem and he's just, the pen is just moving. Well, he's unpacking a mental process, man. And if you can't do that, it means you don't know math. Now we start answering the questions. Only after doing this, after drawing your diagram, now let's start answering. We want all these above 3 questions in terms of, so let's do question number 1. Here's your answers. Here's your answers on the side. But you compulsory, you have to draw this. No diagram, no answers. From now till the end of grade 12. So let's go. Cos 21. Cos 21. According to SOHCAHTOA. According to SOHCAHTOA. What is cos? Adjacent over hypotenuse. What's your adjacent? So you can label it if you want to. You know, that's your opposite. That's your hypotenuse. That's your adjacent. Adjacent over hypotenuse minus the square root of 1 minus P squared over 1, which is minus the square root of 1 minus P squared. And that's your final answer. Now, if you didn't do the triangle, there was no way in heaven you were going to answer this question. Grade 11s, do I make sense? Now, sine 201. What is the relationship between 201 and 21 and a quadrant? Isn't it 180 plus 21? So do it. Do number 2. Don't wait for me. Start with number 2 already. Start with number 2 already. I'm going to do number 2 here on the side because of space. So the answer to question number 2, sine 201, let's reduce that. That's sine 180 plus our reference angle 21. That is equal to sine 180 will remain sine 21. 180 plus is in my third quadrant. Sine is negative. And if sine 21 is P, so what would your answer be? Minus P. That's your answer. Easy peasy, lemon squeezy, pumpkin squeezy, full marks. Ask Rory Sang how he got 100% using all these techniques. Scoring math, 100% in math is a technique. It's an art. Picasso. Let's do the last one. Let's do the last one. Number 3. 2 sine 21 is P over tan 21. Tan is opposite over adjacent. Opposite over adjacent. P over minus the square root of 1 minus P squared. Now, obviously, you can't have a fraction over a fraction. They're testing your algebra skills. How will you make this a single fraction? So, it's very easy, guys. It's very easy. Pay attention. If you still don't know the algebra here, we need to get rid of this to make it 1. So, we multiply it by its reciprocal. So, we multiply it by minus square root 1 minus P squared over P. What we do to the denominator, we do to the numerator. Yes or no? Are you guys following me, grade 11s? What I do to the denominator, I do to the numerator. So P and P will cancel. That and that will cancel. So you're left with 2P times minus, that's 2P over 1, minus the square root of 1 minus P squared over P. Let's simplify this. Because we're multiplying, we can cross cancel. So P and P will cancel. A negative times a positive, so you're left with minus 2 times the square root of 1 minus P squared. And that's your final answer. And there we go, we're done, guys. We're done with this. We now go on to general solution. So for reduction, for identities, who does identities? Ali does identities. When you need to draw a triangle, what method are you going to use? Scrap. Fantastic. Fantastic. It's fantastic. We are now going to do equations and general solution. Put the heading equations. General solution. Now for those of you, I know this is a killer topic. For those of you who don't understand it, we're going to make it as easy as possible. I got another set of acronyms for you. I got another set of acronyms for you in terms of process and procedure. Remember, you walking into a math exam, you are like a heart surgeon. Imagine you walk into, you operating, the patient is on the table. And you decide you want to do whatever you want to do first. You'll kill him. The person won't survive. So mathematics is so clinical. It's such a discipline. You got to follow the processes correctly. Take the right artery. Take the right vein. Connect it to the right artery. You are doing a bypass. You're doing a double bypass. You are the surgeon. Some of you, You just go there, you see maths, you just slice it open, dala what you must, you come out from there and think the patient is going to survive. Can't. Can't. You know what we say? Inna lillahi. You are dead. You killed the patient, brah. What's happening there? I heard something happening here. No? Are we good? Are we good? Right, let's clear. General solution. General solution. Now pay attention. Listen to me. Keiki, look here. You know, come I explain to you. Do any of you even know why we have general solution? No. All right. If I told you sine x is equal to a half, you know x is equal to shift sine a half, you know it's 30 degrees. But, listen to me, if I drew the sine graph, you know the sine graph goes like that. And 30 degrees is somewhere there. But, if I drew a straight line going across, how many times does the red line cut your graph? Twice. So that means there are two solutions, there isn't only one. Yes or no? So all we do for sine, we get three general solutions. We get a general solution for sine. It's your answer, whatever your answer is, plus k times 360, where k is an element of integers. For cos, we say plus minus. Why plus minus? Plus minus a plus k times 360. Because a complete sine graph makes its appearance every 360 degrees. You know that. A complete cos graph makes its appearance every 360 degrees, where k is an element of integers. Tan graph, it's your answer, plus a complete tan graph makes its appearance how many degrees? Very good. K times 180, where k is an element of integers. So guys, when they ask you for general solution, you leave it like this. When they say solve for a or x, now you start substituting your integers for k. Because that's what we said, for k an element of integers, and then whichever of your answers fall within your restriction, those will be your possible solutions, yes or no? So if they ask you for general solution, that's where you leave it. If they say solve, you first give general solution, now you start substituting your integers. So take this down. Take this down. I'm going to show you different forms of general solution. We're probably going to do about 4 examples, different styles. I promise you, you learn these styles. You'll get them all right in your exam. These are just the rules. We're now going to apply the rule to your exam. When we're done with equations, then we're going to do non-90 degree triangles. And then we're done with trigs. So we've done a lot. We did the whole of analytics today. Let's just do a quick recap. What did we do? We did the whole of analytics. In trigs, what did we do? We did identities. We did reduction. We did substitution. We're now doing general solution. Hope you guys took all this down. Onliners, you still there? Ravensmead High School, Western Cape. In the house. Welcome, welcome, welcome. All the best. Empower South Africa. Takalo. Matebe. Thank you, thank you, thank you. Let's go. Right, now watch here. Watch here. Check here. The question will say, give the general solution. let's say, without the use of a calculator, right? 2 sine x minus root 3 is equal to 0. X is an element of 0 to 360 degrees. Right. Now, listen to me. Guys, before we do, you get the single angle, sine 1x. That's called single angle. Then you get the compound angle, where you're going to get sine x plus 10. That's compound. That's single. Compound means you're adding or subtracting. If I tell you you're compounding to my headache, what am I telling you? You're adding to my headache. So just think compound means add or subtract an angle. Then you get the double angle, which is sine 2x. Now I'm going to show you how to do each one of this. So keep this at the back of your mind. Right. So 2 sine x minus 3 equals 0. X is an element in our answer. Let me give you a step-by-step procedure. Let's do it like this. Watch here. Remember I gave you scrap. Let's do another one. SSGR. We can make any acronym with it. Stupid students get rabies. I don't know. Make up something with it. Just remember SSGR. SSGR. The first S is standard form. The second S is use the shift key on your calculator. G, you attach your general solution. And then R, your restriction. So let's do it. Let's follow these 4 steps religiously. Check how quiet is it. Right, put your pens down. Put your pens, I'll give you a chance to take this down. Let's put it into standard form. So standard form would be 2 sine x is equal to root 3. I take that on the other side. Sine x is equal to root 3 over 2. There we go. That's standard form. My right hand side is a fraction. Yes or no? Good. Shift key. So we know x is equal to shift sine. Shift sine root 3 over 2. It's your special angle. In this case, is how much? 60 degrees. Plus k times 360. We attach our general solution. So there's it. Shift key. Now we attach our general solution where k is an element of integers. Now look at your restriction. From 0 to 360. Where is sign positive? Oh, sorry. Where is sign positive? Sign is positive. Sign is positive. Where? Quadrant 1, quadrant 2. Am I right? So, this is quadrant 1. There's your answer for quadrant 1. Here's your answer. Or, you're going to give 2 solutions. Quadrant 2. We know quadrant 2 is 180 minus. It's 180 minus. So, x is equal to quadrant 2, 180 minus 60 plus k times 360, where k is an element of integers. 180 minus 160 is how much? 120 plus k times 360, where k is an element of integers. Take that one down. And you can write in the exam Q1, quadrant 1. You can write Q2. No problem. You're just telling the teacher or your marker you know what you're doing. Our grade 11s are working today. Quite ne?
Mr. Khota, are you vibing today?
Just like you can't believe we are operating. Today math is on the operating table. I'm no doctor, but we can still operate. Kak joke. Check. I said secant, S-E-C. What did you hear? Oh, okay.
Mr. Khota,
No, I said Hassanain. I said
Mr.
secant.
Khota.
I said we're talking about secant, Hassanain. I didn't say T-S-E-K. I said S-E-C, secant.
it's a family show there.
It's
You
a
know, there in the corner there, that's the naughty boy corner. I'm going to put you in the naughty boy corner if any more profanities come from your beautiful mouth.
And I was explaining to them we don't use cosec, sec, and cot. We only use sine, cos, and that's what I meant.
Okay, that's a yellow card, eh?
Hey, you saw the yellow cards last night.
Enough. Wholesale.
Wholesale, my bro. Right, so here goes. So we did the first one, right? The single angle. Okay, let's do a compound angle. Let's do a compound angle. That's a single angle. Let's do a compound. Watch here. 2, 10, x plus 10 minus 8 equals 0. Give me the general solution. I want the general solution. Let's do it together, guys. Let's do it together. Remember, SSGR, stupid students get rabies. SSGR. SSGR. Right, S. First S. So 2, 10, x plus 10. Don't write, let's all do it together. Is equal to 8. Divide by 2. Divide by 2. So 10 x plus 10 is equal to 8 divided by 2 is 4. Right, so the first S. Now we use shift. Shift 10, 4. Don't write. So x plus 10, our reference angle. Shift 10, 4, 75,96. Plus k times 180, because it's for 10. Where k is an element of integers. Now, remember your reference angle is equal to that. Now we solve for x. X is equal to 75,96 minus 10 is 65,96 plus k times 180, where k is an element of integers. So now that's your general solution. It doesn't affect your general solution. When you subtract the 10, you don't subtract the 10 from the k times 180. All right. Let's do a double angle. Somebody had bird seeds this morning for breakfast. What a beautiful day in Cape Town, guys. I love Cape Town. Let's go, another one. Here goes, another banger. 2, 10, 2x minus 8 equal. This is a double angle. Give me the general solution. Let's do it together again. Now watch here. There's a bit of a change here. Watch here. So let's put it into standard form. So 2 tan 2x is equal to 8. Tan 2x is equal to 8 over 2 is 4. 2x, here's it, your reference angle. 2x is equal to shift tan 4, 75,96 plus k times 180 or 180k, where k is an element of integers. So x is equal to 75,96 divided by 2, 37,48, I think. I don't know. Is it 37,48? 98. 37,98, 37,98 plus k times 90. Because you're dividing it by 2, it affects your general solution also. Why? Understanding the differences. You saw the single angle, the compound angle, the double angle. Now, general solution, you're only going to get one, but there are 5 types. So you have to know all 5. They will choose one from them to ask you in the exam. Right, wait. Now there's other ones. Check here. Come guys, behave there. Right, watch here, watch here, watch here, watch here, watch here. Watch this. So this is the one type, the one style where we're solving for x, right? Okay. Pay attention here. Sine squared x minus 2 sine x cos x plus cos squared x is equal to 0. Give the general solution. Right. Now this here is a quadratic equation, guys. So all we do, we break it up, equal to 0. So thus you got sine x minus cos x into sine x minus cos x. Right? Because sine times sine is sine squared. Minus cos x times minus cos x is plus cos squared x. Minus 1 sine x cos x minus another 1 is your minus 2 sine x cos x. So please be on the lookout for quadratic general solutions. Now we got 2 factors, but in this case it's a perfect square. They're both the same. So sine x minus cos x is equal to 0. Now how do I give the general solution? We got 1 for sine, 1 for cos, 1 for tan. How do I give a general solution for this? All right, let me show you. Easy. Take the cos on the other side. Therefore, sine x is equal to minus cos x will become plus cos x. Agreed? Agreed? Now, watch here. Here's a move. Here's a move. Divide this side by cos x. What I do on the left, what I do on the right, I got to do on the sine over cos is what? Shift tan 1, 45 degrees, plus k times 180, where k is an element of integers. Game over. Learn. I'll give you another one like this. Sine squared x minus sine x cos x is equal to 0. Give the general solution. Now guys, they can try and confuse you. Listen to me. Just put down your pens quickly. They can ask it to you like this, or the same question, they can tell you sine squared x is equal to sine x cos x. Guys, don't get confused. This and that is the same. Because you're just taking this onto the other side. Right. Give me the general solution there. Come, you ought to be done. Those of you who are good, you are done already. Onliners. Let's go, let's go, let's go. Let's see who's a boss. You get this one right. You're on. Skoko. You are Skoko.
Mr. Khota, are we looking for time there? My stomach is making some noises there.
Look, we're only here. We're going to go in. We'll go in for break at 1:45.
1:45. Okay.
Yeah, we came in here 11:15. So 12:15, we're in here. It's already 12:25. We've got 20 minutes. We'll do the non-90-degree triangles after this, and then we go for break. 1:45 till 1:30.
Okay, no problem.
Oh, food has arrived. Let's not say that. I can hear their stomachs growling already.
Yeah, no, but we're gonna add a nutritious meal to the mix.
Okay.
Not the
What do we have?
acne, not the conventional acne we skipped at this time around.
Okay. I thought we're getting real cups of acne.
No.
Gatsby's.
Not today, man.
Gatsby's.
We will fall asleep. No, me and you can cup a Gatsby after this thing.
Right, let's go. Right, highest common factor. Please tell me you guys did this. Please tell me. Let me just see. How many of you did this here? Well done. Give yourselves a nice round of applause. Well done. So now you got sin x equal to 0 or sin x minus cos x equal to 0. X is equal to shift sine 0 is 0 degrees plus k times 360, where k is an element of integers, or x is equal to 180 degrees plus k times 360. You must give two solutions for sine. And in this case, or we're going to do what we did the last time. Sin x is equal to cos x. Divide by cos. By now you know sin x over cos x is equal to 1. Tan x is equal to 1. Shift tan 1. X is equal to 45 degrees plus k times 180 for tan, where k is an element of integers. You will get 6 marks for this. Did you all get your 6 marks? Good. Very good. Oh, yeah. Right. Come grade 11s. Let's talk. Now check the next one out. Sure, the next one is going to hit you for 6. Next one is Mike Tyson, Baba. A right hook, uppercut. Next one is going to slut you flow. Let's go. Check the next one out. Bra, you get the next one right. You face. Sin x minus 45 is equal to cos 2x. Give me the general solution for 7 marks. Shh. Come, guys. Now, guys, this can even be in trig graphs. They can say this is f of x. Where is f of x equal to g of x? So you have to find all the points of intersection. Let's say, come, let's actually even do that from x being an element of 0 to 360 degrees. Right, so give me all the points. Show, without sketching the graph, show algebraically the points of intersection or give the general solution. Same question. You do this one, you're a boss. You can't divide by cos because this is cos 2x. You can't, remember, cos is attached. Come guys, come guys. 7 marks, you got 3.5 minutes to do it. Guys, I'm giving you all the different scenarios, all the different possibilities that you could see, so that it can be familiar to you in your exam. You will know how to unpack it. Most of you fail because you don't even know where to start. What's the opening line? Come on, liners. Are we all good? Onliners, tell us where you're coming in from. Keeping up with Malanta. Shout out to Mrs. Sibande. Mrs. Sibande, you plug them all in. 10 brownie points to you. Big shout out. What did you get? Somebody sent a question, somebody sent an answer. Somebody sent an answer. Let's check. What did they say? Don't think so. Kenneth. Right, let me show you the art of this. Let me show you the trick of it. Let me take you out of your misery. Watch here. This is where you begin. You convert the cos to sine. Watch here, watch here, watch here, watch here. Sine x minus 45 is equal to sine. Convert the cos to sine. 90 minus 2x. Because sine 90 will become cos. Yes or no? Don't write, don't write, don't write. Let me show you what to do. That's only step 1. Step 2. Watch here. The minute you do this, you cancel the 2 sine. Listen. And now you do this on the side. You split it up. Like that. So you're going to get 2 solutions for sine. For sine, how many answers must you get? 2. 0 degrees plus or 180 degrees minus. Yes or no? So you do it. I'm showing you an art of doing it. You do it exactly the way I'm doing it here on the screen. You can do it in your exam. I'm giving you a copy and paste model, template. So watch here. So now, 0 degrees plus x minus 45 is equal to 0 plus this will still remain. If you want to write in 0 plus, you can. You don't have to. 90 minus 2x plus k times 360, where k is an element of integers. Let's solve for x now. X, there's it, minus 2x comes on that side as plus 2x, is equal to 90, we leave. Plus 45, minus 45 comes on the side as plus 45, plus k times 360, where k is an element of integers. X plus 2x is 3x. 90 plus 45 is 135, plus k times 360, where k is an element of integers. So x is equal to 135 divided by 3 is 45, plus k times 360 divided by 3 is 120, where k is an element of integers. That's your first solution. Now we go on to our second solution. Or x minus 45 is equal to 180 minus 90 minus 2x plus k times 360, where k is an element of integers. Let's remove the brackets and solve for x. X minus 45 is equal to 180 minus 90 plus 2x plus k times 360. My hands are getting sore now of writing. Let's go. So x minus 2x, 1x minus 2x is minus x. 180 minus 90 is 90. 90 plus 45 is 135 plus k times 360, where k is an element of integers. We want x. X is equal to divide by negative, divide by negative, divide by negative. And there we go. There's your 7 marks. You do it exactly the way we've done it here. Okay. Copy and paste. Now you can find from 0 to 360. You're not yet done, eh? You're not yet done. Because now we must put in all our integers for k. So you're going to put 0, 1, 2, minus 1, minus 2. And then find all your values that fall within 0 and 360. And you're going to do the same thing here. 0, 1, 2, minus 1, minus 2. If they just told you give the general solution, this would be your 2 final answers. If they say solve for x or give all possible solutions, let's say they told you to find all possible solutions, then you now start substituting for k. 0, 1, 2, minus 1, minus 2. And you see whichever of your solutions fall within your restriction. But this is how we unpack this type of a problem. All right. We got about 10 minutes left before break. We're almost there. Quickly, I hope you all know the sine rule. A side over sine of its opposite angle is equal to any other side over sine of its opposite angle. Yes or no? Sine A over A equals sine B over B equals sine C over C. And the cos rule? In any triangle ABC, A squared is equal to B squared plus C squared minus 2BC cos A. Must I write it for you?
Question.
This question here is worth 7 marks. 7 marks, Katlejo. 7 marks. Okay, I hope you all took this one down. Are you all done with this one? Can I erase? I'm going to show you a technique of answering the trigs in 2D. You're going to love it. It's so easy. It's easy. It's only done in 2 steps. Those trigs on different planes, where you got a 90-degree and a non-90-degree triangle. It's only done in 2 steps. I'm going to show it to you now. Watch here. Shh. Can I erase? Are you all done? Who's still writing? Good. Right. Let's see. Come on, clear frame. Come on, brah. Right, here goes. Now watch here. Right. P, Q, R, S. Let's make a dotted line there. That is parallel to that. That is angle theta. That is alpha. That is beta. That is X. Show that H, PR the height. Show that H equals X sine beta over sine alpha tan theta for 5 marks or 6 marks. Right. Here goes. Right, now listen to me. I'll show you art. Let me show you the technique first. The technique is that you will get a 90-degree triangle and you'll get a non-90-degree triangle. For a 90-degree triangle, we know we got to use SOHCAHTOA to solve. And for a non-90-degree triangle, we're either going to use the sine rule or the cos rule. What's the aim? Step number 1. The aim is to rename the common side. Rename the common side. Let me just lift that slightly. There we go. Rename the common side first. Because the common side is the boundary between the two. The common side is the border between the two. Now think about it. It's so easy. I promise you this is going to be so easy. Okay, pay attention. Let's go. So my common side here is QR. That's Q. Right, put your pens down. Just for explanation purposes, I'm going to call the one triangle 2. Right, pay attention. The border, so I use the word border, right? It's like the border of South Africa, between the border of South Africa and Zimbabwe. So South Africa is triangle number 1, 90 degrees. Zimbabwe is triangle number 2. I got passengers in Zimbabwe. I want to bring all my passengers from Zimbabwe, show that H. Remember, H is in triangle number 1. H is in triangle number 1. My question is in triangle number 1. So I want to bring all my passengers from Zimbabwe, put them into a taxi, bring them to the border, change the taxi, and bring them to South Africa. The taxi for Zimbabwe is triangle 2, non-90 degree. The taxi for Zimbabwe is either the sine taxi or the cos taxi. The taxi for South Africa is what? SOHCAHTOA. So watch. In our answer, we're starting in Zimbabwe, triangle number 2. Because the question got sine in it, I'm leaning towards using the sine rule. So now watch here. We're using the sine rule. Triangle 2, we're putting them in a taxi. We're going to put all these alphabets in a taxi and we're going to bring them in that taxi to South Africa. Watch. So what did I say? What's the aim? To rename the common side. Yes or no? Right. Pay attention. It's easy. Let's start. QR, a side over sine of its opposite angle over sine beta is equal to any other side, x, over its opposite angle, sine alpha. So I only want QR. I only want the border. So we times this side by sine beta. We times that side by sine beta. QR on its own is known as what? X sine beta over sine alpha. Yes or no? And isn't that where we're going with it? So we already got the first part. Now we go into triangle number 1. It's 90 degrees. So we use SOHCAHTOA. So if that is theta, that is parallel to that. That is also theta, alternate angles. Now this is my opposite side. That is my hypotenuse. That is my adjacent. I need H and QR. I need QR and I need H. So which one is it? If that's my reference angle there, I need QR and H. O over A. Opposite over adjacent. Opposite over adjacent is what? 10. So watch here. Here's your answer coming up. Tan theta is equal to opposite over adjacent. So tan theta, we're talking about triangle number 1, is equal to, what's this? H, opposite, over A is QR. I don't want H over QR. I only want H. So times QR, therefore H equals QR tan theta. But is QR called QR? No. We take that and we plug it into here. Here's your final answer coming in. Instead of QR, what must I put? X sine beta over sine alpha. That's QR tan theta. And there we go. There's our final answer. Done in 2 parts, 2 steps. Slaughtering on slag. Maths vandaag.
Maths assassins.
Math assassins.
Here we go.
We're slaughtering math today, guys. Kurbani met math.
Make maths your prisoner.
We take no prisoners, brah.
Alcatraz, and so on. Are we set for lunch now, Mr. Khota?
Ish, yes we
I
are.
can smell something's burning, some brain,
Yeah,
or
yeah,
some
yeah,
toast
yeah,
or
yeah.
something that's burning.
Are you guys hungry? Or you want to carry on? You hungry? You want to go for break now? No. Mohammeds, you heard that? They are here for 2 days boot camp. Mohammed. Guys, we're going for break. We're going to come back. We're going to come back and we're going to break till 1:30, guys. You got 45 minutes. Enjoy your break.
So there we go, guys. We're breaking now for
Lunchtime.
lunch. When do we resume, Mr. Khota?
1:30.
1:30. We will be back. We're just taking a lunch break. Thank you so much.
Onliners, enjoy your break. We're going to do more of this after break. I'm going to do 2 more for you. Enjoy break, enjoy break, enjoy break.
1, 2. Welcome back. Welcome back, learners. Kindly take your seats. We will be resuming with the last part of the workshop. Welcome back. We're about to start now. If you can take your seats. Thank you. We hand over to Mr. Khota. Mr. Khota, take the show away.
Okay. Let's wait for all our learners to come in. Settle down. We got a minute to go. Okay. Welcome back. After lunch, this is our last session. Welcome, onliners. Let's play with math. Nice. Okay. So we ended up with that one. Let's try another one, guys. Let's try one more. Take this one down. Take this diagram down. That is parallel to that. That is angle theta. This is triangle D, E, F, G. This is X. That is alpha. That is beta. Show that DG is equal to X sine alpha over sine alpha plus beta cos theta. 6 marks. There we go. Take this diagram down. Welcome back, grade 11s. Very proud of you all. An entire 2 days from 9 to 3, and we've got a full house. Nobody has left the scene. Nobody has left the venue. You guys are working magnificently. So thank you all to our on-siters as well as all our onliners. Take this diagram down. Welcome back, South Africa. Fanyana Sean. How's it? Getting there. We're getting there. Kasajo. Big shout out to Kasajo. Good Sunday with Maths Fanyana. Botse Secondary School. Big shout out to you. Cultura High School, Mrs. Sibande, much appreciation. My sister, Komotso, my sister from another mister. Let's go. Right. Guys, we got DG. So identify what is your question. Your question wants DG. So let's just make a line there. Let's just color that line in. They want DG. Shh. We got triangle 1, we got triangle 2. All my alphabets are in triangle 2, so I have to start in triangle 2. Triangle 2 is non-90 degrees, so I have to use the sine rule or the cos rule. I have to rename the common side. What's the common side? EG. Okay, now let's look in our question. We got a sine, so I'm going to apply the sine rule. So EG, watch here. Put your pens down, guys. Pay attention. We're applying the sine rule in triangle 2. EG over sine of its opposite angle over sine alpha is equal to any other side, x, over sine of its opposite angle, that angle there. Do we have this angle here? Yes, we do. Because we got alpha and beta, sum of angles of a triangle, it's 180 minus alpha plus beta. Yes or no? Sum of angles of a triangle. Yes or no? So that means EG over sine alpha is equal to x over sine 180 minus alpha plus beta. There we go. Let's do this. So EG over sine alpha is equal to x over, let's reduce this, reduction. Sine 180 will remain sine alpha plus beta. 180 minus is in my second quadrant. Sine in my second quadrant is positive. So I want EG on its own. I don't want this. I'm just applying the sine rule. I want EG on its own. So times sine alpha times sine alpha. Sine alpha will cancel on that side. EG is equal to x times sine alpha over sine alpha plus beta. We don't think we're right. We know we're right. Check that. X sine alpha over sine alpha plus beta. X sine alpha over sine alpha plus beta. We know we're heading in the right direction. Now let's go into triangle number 1. Triangle number 1 is 90 degrees. We're going to be using SOHCAHTOA. That's angle theta, that's angle theta. These two lines are parallel, alternate angles. That's my opposite, that's my hypotenuse, that's my adjacent. I need EG and DG. I need EG and I need DG. So what is that? EG and DG is A over H. And A over H is what? Sine, cos, or tan? Cos, very good. So I'm going to start off with cos theta is equal to EG over DG. I want DG. This is adjacent over hypotenuse. Here I just use SOHCAHTOA. I want DG. So this is an equation and I want you guys to know this. If you want DG on the top, you can flip this side, you can flip that side. So DG, therefore DG over EG. If I flip this side, I got to flip that side. Is 1 over cos theta. I want DG on its own times EG times EG. So what do I have? DG is equal to EG over cos theta. But EG is not called EG. EG, I can substitute it, is called that. So here's your final answer coming up. Therefore, DG is equal to, instead of EG, I'm going to put x sine alpha over sine alpha plus beta. There we go. That's EG. Cos theta is at the bottom. So I leave cos theta at the bottom. And there we go. There's our 6 marks. 3 marks on this side. 1, 2, 3 marks here. 1, 2, 3 marks there. There's your 6 marks. So I gave you 2 in terms of the cos sine rule. We're going to do 1 in terms of the cos rule, and we are done. We then go into Euclidean. Take it down, guys. Oh, okay. They give you another one here, another clever one here to test you about the sine rule and cos rule. In fact, let's do one after this. We're going to do two more. One in terms of the cos rule, and then one from this past paper. We'll do two more. Then we'll go into Euclidean. Right, so you guys got this down. Onliners, we still there? Are you guys still alive? Are you guys still alive? Still watching, my sister? Let's go, let's go, let's go, let's go, let's go. So this is step number one. That's step number one. And that is step number two to get to our final answer. So this is step number one, and that's step number two. Step number one, we use the sine rule. Step number two, we use SOHCAHTOA. All right, while you guys taking down this calculation, let's see who's sharp. I'm going to put up another one here. Those of you who are done with this, you can start with the next one already. Let's see, what do I remember what it looks like? Okay, it looks like that. It looks like that. It looks like this. It looks, no, it doesn't look like that. Come on. Okay, it looks like that. It looks like this, like that. We've got a dotted line coming there. That is parallel to that. That's 90 degrees. That's angle beta. That side is equal to that side is equal to x. This angle is angle alpha. That is h. We can call this triangle LMNO. Show that h equals x tan beta square root 2 into 1 plus cos 2 alpha. And where's h? That's h. That's h. Lm equals h. Lm equals h. Show that h equals x tan beta square root 2 into 1 plus cos 2 alpha. Nice one. Okay, let's erase that. That's done. And all this is done. Let's go, guys. Let's go, let's go, let's go, let's go. We do the same thing. Only thing, we're not going to be using the sine rule. We're going to be using the cos rule. We got an isosceles triangle there. Triangle MNO is isosceles. So if this is x, that is x. If that is alpha, that is alpha. And then obviously angle N is 180 minus alpha plus alpha is 2 alpha. That's how you complete your diagram. That's how you complete your diagram. We need to rename the common side And the common side is MO or OM. Let's go, guys. Let's go, let's go, let's go. I'm doing this one and we're going to do another one from a past paper. Okay, let's go. Let's call that triangle 1. Let's call that triangle 2. So in triangle number 1, I'm going to be using the cos rule. So OM squared is equal to one side squared plus another side squared minus 2 times the product of the two sides cos of the reference angle, which is 180 minus 2 alpha. That's the cos rule. Now let's simplify this. Be careful now. Okay, put your pens down. Let's all do it together. Otherwise you might get confused as we're doing it. So OM squared is equal to 1x squared plus 1x squared is what? 2x squared. Minus 2x times x is 2x squared. Cos 180 will remain cos 2 alpha. 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. And negative times this negative will make it a? Alright, now be careful. So therefore OM squared is equal to, be careful. You can't add the 2 because this is an unlike term. So we pull out the highest common factor, which is what? 2x squared. So I'm left with 2x squared divided by 2x squared is 1 plus cos 2 alpha. So OM is equal to the square root of 2x squared into 1 plus cos 2 alpha. My only perfect square here is x squared. So we take that out. So OM is equal to x square root. So I took out, I'm done with the x squared. So I'm left with 2 into 1 plus cos 2 alpha. Now there we go, look at that. There's the x, there's the x. There's all of that. What's the only thing we're short of? Tan beta. Now if we don't get it from triangle 1, where are we going to get that from? Triangle 2. Now triangle 2 is 90 degrees. I need h, so that's beta, that's beta. We always work with beta inside the triangle, not outside. I need LM and OM from beta. That's tan. So, ka, to, wa. I need opposite over adjacent. So tan beta is equal to opposite over adjacent. Tan beta is equal to, what's your opposite? H. What's your adjacent? OM. But I only want H. I only want H. So I times this side by OM. I times that side by OM. Therefore H is equal to OM tan beta. But OM is not called OM. OM is not called OM. Let's take that and let's put it into there. Here's your final answer coming up. Therefore, H is equal to, instead of OM, X, that's outside. Tan beta, that's outside. And then I have the square root of 2 into 1 plus cos 2 alpha. And there we go. You will get 6 marks for that. Simple rules, guys. Simple rules. We've done 3 examples here. If you guys get this thing wrong in your exam, there's something seriously wrong with you. It means you've just wasted an entire 2 days. Remember, you sacrificed 2 days. Make these 2 days count. Exams are around the corner. When do you guys write you're writing a school paper or a district paper? Circuit paper. Or you're writing your school is setting your paper. Who's setting your paper? School. I know most learners in Gauteng are writing the district paper. The district will set a paper. I know we're collecting our papers from the district tomorrow. So we're about 2 weeks away. When do you guys start writing? Not this week, the following week. Am I right? You've got some time. Master what we've done. Practice on what we've done. And ace your exams.
So, Mr. Khota, what I have done is for all participants that have logged on online, as well as our cohort that's present here today, or most of you, I have emailed you the links of Maths Paper 1 and Maths Paper 2. So you can check your inbox after the session. So you can use some of these videos as part of your final examination revision. How's that, Mr. Khota?
Excellent, excellent. Did you guys hear that? Yesterday's whole session and today's whole session, if you've registered with Awqaf, it's already been sent to your email. You just click on the link and you'll get yesterday's workshop and today's workshop. So check your inbox after the workshop.
Or if you did not receive the email,
Yeah.
all that you need to do before you leave here today, come and scan this QR code. That's the final work or homework I have for you. Log on to the Awqaf website. You get the link here, awqafsa.org.za. There is a maths workshop page that has all of these videos. So that's going to help you. Thank you.
Lovely, lovely. Thank you, Asanain. My G.
No, you're the top G, Mr. Khota.
You're my OG.
No, you're the top G. Oh, maybe I'm the top G and you're the OG.
OG.
Yeah. Oh.
Let's go. Let's go, let's go, let's go. Come grade 11s. Okay, so now let's see this one. Right, this is the one that came out of a past paper, right? Are you guys ready for it? Onliners, can we delete? Can we clear the frame? I'm sure you all took it down. I'm sure you all took it down. Here we go. Right. So they didn't give you a hectic diagram. From the past paper, they didn't give you a hectic diagram. This is what they gave you. Check it out. They only did that. They did this. They did that. They gave you that as 2x. Take it down with me. There's P. That's X. That's R. That's 3. That's theta. That's Q. Right. Show that. Question number 1. Show that cos theta is equal to x squared plus 3 over 4x for 3 marks. Question number 2. If x equals 2,4 units, if x equals 2,4 units, calculate theta, find the value of theta. And question number 2, calculate the area, find the area of triangle PQR. And there we go. Here we go, here we go, here we go. 3 marks. And 3 marks. 3, 6, 9 marks on these 3 questions. So let's just double check that we got everything in. That's x, that's 2x, that's r, that's p, that's q, that's theta, that's 3. Let's go, let's go. Let's answer this, guys. Take this one down. Take this one down. Let's answer it here. Answer to question number 1. Cos theta, they're referring to cos theta. All right, let's do it. Is this a 90-degree or non-90 degree triangle? Non-90 degree. And because they use cos theta, what am I going to be using? The cos rule. So we're going to start off with x squared because theta, listen, theta is your reference angle. So the side opposite. So we're going to start off with x squared is equal to 2x squared plus 3 squared minus 2 into 2x into 3 cos theta. This is our cos rule. Right, now all we have to do, what do we need to do here, grade 11s? We need to make cos theta the subject of the formula. Yes or no? Let's do it together. So we have x squared is equal to 2 squared is 4x squared plus 3 squared is 9 minus 2 times 2 is 4 times 3 is 12x cos theta. Okay, let's see. X squared minus 4x squared minus 9 is equal to minus 12x cos theta. Remember, I need to get to cos theta. So 1x squared minus 4x squared is minus 3x squared minus 9 is equal to minus 12x cos theta. Pay attention, guys. Now I want to get rid of the negative. So we're going to divide by minus 1. So we're going to change all these signs. That will change. That will change. So 3x squared plus 9 is equal to 12x cos theta. I'm going to put a tick there. I'm going to move over to the side. I'm just going to move over to the side. Those are our questions. So I'm moving from there to here. So 12x cos theta is equal to 3x squared plus 9. So what I want to do, I need x squared plus 3. So I'm going to say 12x cos theta. I'm going to take out 3 as my highest common factor, and I'm going to be left with x squared plus 3. I'm going to divide this side now by 12x. I'm going to divide that side by 12x. And here comes my final answer. Cos theta is equal to 3 goes into 3 once, 3 goes into 12 4 times. There's your final answer. X squared plus 3 over 4 times x is 4x. Game over. Done. All we did is we used the cos rule and we made cos theta the subject of the formula. That's all we did. No rocket science. But we had to make sure that our algebra was on point. If you messed up anywhere with your algebra, you would have never got the correct answer. That's why I did it step by step. Remember, guys, I'm not working through a memo here. I don't have a memo here. Every question that I'm doing it with you for the first time as if we are all writing the final exam together. Okay? Now let's see. If x equals 2,4 units, find theta. So, okay, all these questions are related. So what would I do in the exam? I would then take the 2,4 units and I would put it here for every x. And then we solve for theta. So let's do that. Let's call that 2.1, 2.2. Let's answer question 2.1. Remember, the minute the questions are related, like 2.1, 2.2, it means that they follow through. The answer from the one can be used into the calculation for the next. Let's go, guys. Here goes. Question 2.2. Onliners, are we there? Are we still alive? Are we alive? Send us your comments, guys. Are we all good?
I think the online is stepped out, Mr. Khota.
Why are you dividing by -3? No, you could divide by 3 on both sides also. You could. Maths is mathsing. Shumika. Hello, Shumika. Welcome, welcome, welcome. Right. So now we got cos theta is equal to x squared. So 2,4 squared plus 3 all over 4x. 4 into 2,4. So cos theta is equal to, let's go to our calculators, 2,4 squared plus 3, divide that by 4 times 2.4. 73 over 80. So theta is equal to, we use the shift key on our calculator, shift cos 73 over 80. Boom. 24, to 2 decimal places, 24,15. In fact, you can do angles you do to 1 decimal place. Whenever you're doing angles, you do it to 1 decimal place. So 24,1. 24,1 degrees. And there we go, we're done. I want you to do the last one. Number 2.2, find the area of triangle PQR. Come on, that's easy. You got theta, you got x. So walk in the park. You got theta, you got x. They just want to see, do you know how to apply the area rule? Onliners, you following me? Let's go, let's go, let's go, let's go, let's go. Right, I'm now going to answer question number 2.2. I'm now going to answer question number 2.2. Find the area of triangle PQR. So we got x, so 2 into x here is 2,4. So 2 times 2,4 is 4,8. And we got theta is 24,1. Now, which sides, which angle? Remember, area is equal to half of a side times another side times sine of the included angle. Area is equal to half of a side, 4,8. Multiply by another side, 3, times sine of, it's got to be the angle between the two sides of 24,1. So area is equal to, let's go, let's do that. A half times 4,8 times 3 times sine 24,1. Boom. 2,939. 2,939 or 2,94 units squared. 2,94 units squared. And there we go. We're done with the area rule. These are possible exam questions, guys, from past papers. Not difficult. Why? Because you know the rules. Let's go into Euclidean. Let's go into Euclidean. Okay. Now, in Euclidean, I just want to go through all the theorems with you quickly. I don't want to have to, let's see how much time we got. Okay, we got a little bit of time. So let's go, let's explain to you quickly the theorems. I'm not going to do the proof of the theorems. That's bookwork that you can just learn from your book. Which theorems? Now, let me tell you what to learn in Euclidean. Right. The first thing you need to learn is Pythagoras. They're going to give you Pythagoras in a circle. Learn that. Second thing we need to learn is the proof of certain theorems. So which proofs do we need to know? Line drawn from center of a circle to the midpoint of a chord. Line drawn from center of circle to midpoint of a chord. You know which one is that? It looks like that. Line drawn from a center of a circle to the midpoint of a chord meets it at 90 degrees. That's the first one. The second proof you need to learn is I'm just writing it in shorthand. Exterior angle at center is equal to 2 times angle at circumference. The next one we got to learn is your tan chord theorem. Right. You need to know parallel lines, definitely. Parallel lines. Alternate angles, corresponding angles. Isosceles triangles in a circle. You must look for this using your radii. Obviously, you need to know some of angles of a triangle, and now you got to know all your circle theorems. So number 5, you got to know how to apply all your circle theorems to solve for angles or to prove angles equal. So this is just the broad spectrum Euclidean of what you need to know. Now let's go into your theorems. Let's talk about all your different theorems. Then we will start with the application into exam style questions. And you'll see it's very easy. Very, very, very easy. There's also a technique. There's a style to answer questions. Once you get the technique, I promise you, you'll have no problems. Right. So this is your broad spectrum of what you need to know. And obviously, sometimes, very rare, you need to know congruency. Now, you know congruency when we compare two triangles, side, 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 angle, angle, right angle, hypotenuse, side. This is grade 9 work. And then from grade 10, you had the midpoint theorem. Again, very rare. Do you guys remember this from grade 10? That a line from the midpoint of one side to the midpoint of the other side becomes parallel to the third side becomes parallel to the third side and half the third side in length. It's good to know it, but this is very rarely asked. Number 6 and 7 is very rare. But it's good to know it. Just have it in your toolbox. A line, remember midpoint theorem in grade 10. A line drawn from the midpoint of one side to the midpoint of the other side makes it parallel to the third side and half the third side in length. Okay. Let's go through our theorems. Now guys, you got to memorize the theorems. And it's not difficult. If you can picture the circle, now you know what goes into the circle. Either a cycle, oh, we forgot to put, okay, but I put, no, apply all the theorems. Obviously, you got to know cyclic quadrilaterals. Cyclic quads, and number 9, parallelograms, palms, a rhombus, a kite. Properties of a rhombus, properties of a kite, they're easy. A rhombus is a tilted square. So if you know what's a square, the only thing is that in a rhombus, each angle is not equal to 90 degrees. Opposite sides are parallel, all the sides are equal, and the diagonals bisect each other. A kite, we know, adjacent sides are equal, diagonals bisect at 90 degrees. A trapezium is only one pair of opposite sides parallel. That's all that there is to a trapezium. So you've got to have a picture. It's not like you're studying it or you're swatting it or you're memorizing it. You just have a picture of it in your mind and know what the shape is. So let's see. We got the shape of a circle in our mind. Okay. So if we got a shape of a circle in our mind, the first theorem that comes to mind is my cyclic quadrilateral. So let's talk about the cyclic. Now, I'm going to show you how to remember. Remember, I'm not only here to deliver the content. I'm here to show you an art of memorizing. You've got to picture it in your mind. So let's go. And I'm going to show you by the end of today. We're going to close our eyes. We're going to all state what all our theorems are. You'll see by the end, by the time I'm done with you here. Watch. Okay, so we're done with that. Let's draw a circle, guys. Watch here. Okay, so the first thing we're going to do is we're going to draw a circle. Right. What did I say? When you're looking at a blank circle at the moment. Let's fill the circle in. So the first thing I'm going to do is do that. We all know when 4 points touch the circumference, what type of a quadrilateral is that? Cyclic. So that means my first theorem about a cyclic quadrilateral is that my opposite angles are supplementary. They add up to what? Right, so the opposite angles of a cyclic quad are supplementary. They add up to 180. Wait, we're not yet done. We're not yet done. Don't write. Don't write. I'm showing you how we're going to go along with this. The next one we're going to do is in a cyclic quad. I'm not yet done. If I extend any side, we know that the exterior angle of a cyclic quad, the exterior angle of a cyclic quad is equal to the interior opposite angle. Yes or no? Right. Okay. Now, let's look. Let's take, okay, so we're done with the cyclic quad. Now, this one here, don't forget this one here. This is one that many people forget. Okay. You got a common side. You got a segment, a line segment. You know that a segment, common segment, subtends equal angles at the circumference. It's one line segment. Subtend means to extend. So you put your 2 fingers on the edge of the line segment and you subtend it, you extend it to the circumference. So obviously that angle is equal to that angle there. Right? So line drawn, so we can say this is a, which one is this? What do we call it? No, it's not angles in the same segment. Common side. How do we phrase it? How do we phrase it? What's our theorem? It's not angles in the same segment. Angles subtended by a common chord. Equal chords, that's the one I'm looking for. Thank you. Equal chords or equal chord subtends equal angles at the circumference. That's number 3. So number 1, number 2, number 3. Okay. Now, obviously, now that we got this bow tie or this butterfly, now we're going into number 4. Right. So number 4, when we have a bow tie or we got a butterfly and all 4 points touch the circumference, then we know angles in the same segment. This is called angles in the same segment at the circumference are equal. Right, take these 4 down. Take these 4 down. We're going to do about 11. But remember, we're not I'm not doing it in order. I'm not calling it theorem 1, theorem 2. I'm just saying this is all that you need to know in your toolbox. So just draw your circles rough, guys. Don't take too much time because I'd like to move on. I need to go on to theorem number 5. Right. Now, as you're taking it down, I want you to remember these pictures in your mind. Remember the cyclic quad. Remember this equal chord subtending equal angles. I want you to remember the bow tie or the butterfly, where all 4 points touch the circumference. Okay. Remember, I'm going to teach you to remember this. So I'm not only showing you what it means. When you walk out from here today, you must know all 11 in your brain, in your mind. Okay. So you got to have an imagination. You got to have a picture in your mind. Come, guys, pay attention. Okay, I'm going to erase the first one. So we did number 4. Let's do number 5. Let's do number 5. Here's number 5. Now what happens? O is the center of the circle. When you have a bow tie from the center of a circle. So here, guys, angle at center is equal to 2 times angle at circumference. So if this is 20, the angle at center is 40. So just picture this, the bow tie, all 4 points not touching the circumference. It's starting from the center of the circle. So here, angle at center is equal to 2 times angle at circumference. Right, now we're going to the center of a circle. Five. Number 6. Pay attention here. Pay attention. So now we got what we call like a spearhead shape. A spearhead, you know, a spear, asahai. A spearhead. So exterior angle at center is 2 times angle at circumference. Exterior angle at center is equal to 2 times angle at circumference. And it can also look like this, guys. Watch here. So let's call this 6a and let's call this 6b. It's the same thing. It's the same theorem. So when you got a quadrilateral that looks like that, all 4 points don't touch the circumference, only 3 points. Then exterior angle is 2 times angle at circumference. It's the same theorem, guys. It's the same theorem. Okay, so we're done with the exterior angle. How about, you know, the famous one? Line drawn from a center of a circle to the midpoint of a chord. O is the center. That's not a radius. It's just a line drawn from the center of a circle to the midpoint of a chord, meets it at 90 degrees. So line drawn from center of circle to midpoint of a chord. It meets it at 90 degrees. Perpendicular to the chord. Right. Now we're talking about lines. We talk about the center of the circle. So what do you think our next one is going to be? A diameter subtends a 90 degrees at the circumference. Remember, angle in a semicircle. So what number was this? This was number 7, eh? This is number 8. So a diameter subtends a 90 degrees at the circumference. So this is called angle in a semicircle. "90 degrees at the circumference." Right. We're still with the center of a circle. We're still with the center of a circle. A radius is 90 degrees to a tangent. So now we're introducing the concept of a tangent. The radius is 90 degrees to a tangent. Any tangent. The minute you have any radius and you got any tangent, you know it meets it at 90 degrees. Now comes our very important one, dealing with tangents. What do we know? 10-chord theorem, am I right? So let's talk about the 10-chord theorem. That's number 8. This is number 9. Now let's do number 10. Let's do number 10. So now we're going to do the 10-chord theorem. So you must have a cyclic triangle. All 3 points must touch the circumference. And then we have a tangent. So angle between tangent and chord is equal to the angle in the alternate segment, subtended in the alternate segment at the circumference. 10-chord theorem. So this angle here on this side is equal to that angle there on that side. So this is what we call the 10-chord theorem. The angle, that's your reason, angle between tangent and chord is equal to the angle subtended by the chord at the circumference in the alternate segment. I know it's long, it's a mouthful, but sometimes in the exam they'll say complete the theorem. You'll just have to state it. They'll give you 2 marks just for stating the theorem. At the circumference in the alternate segment. There we go. Angle between tangent and chord is equal to the angle subtended by the chord at the circumference in the alternate segment. So now we're not yet done with tangents. Come on. Last one with regard to tangents. When I got 2 tangents meeting at a common point outside a circle, they are equal in length to where they touch the circle. Am I right? And that's the last one. So let's go. So we're into the last one. So that's number 10. Now we're now going to do number 11, the last one. I'll just do it here at the bottom. So let's draw 2 tangents. 2 tangents meeting at a common point. So let's say you had a tangent going like that. And you have a tangent going like that. And there we go. 2 tangents meeting at a common point outside the circle. 2 tangents meeting at a common point outside the circle are equal in length to the point of contact of the circle. Remember, because that tangent can't be equal to this tangent. They're only equal to where they touch the circle. At the point of contact, to the circle. And there we go. That is number 11. And there we go. Now we're done. Now I'm not sitting with the theorem here. How did I manage to remember all of it? Obviously, I just pictured the circle in my mind and all the different diagrams and all the different variations. These are the only variations you can get on a circle. Now remember something, that this is a center of a circle. It's going to a tangent, so that's a radius. So obviously that will be 90 degrees. That will also be 90 degrees. Then that side is equal to that side, and it forms a kite. What does it form? A kite. And what do we know about a kite? We know that the diagonals also meet at 90 degrees. Very important pieces of information. Okay, 2 tangents meeting at a common point outside the circle are equal in length at the point of contact to the circle. All right, now before we get into circle geometry, let me just tell you the strategy of geometry. Euclidean is very easy. You start from the known, whatever your known is, and you move to the unknown. And you use your mark allocation as a guide. If it's 1 mark, it's a direct link. 2 marks, maybe it's also direct, but maybe they just want a reason. 3 marks, it means make 1 more stop and then get to your destination. 4 marks, 5 marks, 6 marks means make many stops and use your theorem. But where do we begin? With the known. So if they tell you something is 20 degrees, then you start with the 20 degrees and start relating all the angles that are equal to 20 degrees. Okay? So that's the simplest way I can put it to you. You start with the known, moving and navigating towards the unknown. Unknown is what you need to find from the question. Yeah. And you got to prove that it's parallel. Yeah. Look, if they want you to prove parallel lines, then all you need to do is to prove either one pair of opposite sides alternate, the angles alternate, or you prove corresponding angles. Therefore, the lines will become parallel. You with me? I'll show you. We're going to do some of these examples now. Okay, let's start with the Pythagoras problem here from a past paper. Let's start with a... All right, let's take this one down, guys. Take this one down with me. Let's go. Let's do that. There we go. It's worth 5 marks. In the diagram, O is the center of the circle. T lies... Oh, no. This one says just prove the theorem which states. No, we don't want to do prove the theorem which states. Oh, okay, no, you know what? Just take that out. The next one also, the diagram looks very similar. That one, your first 5 marks was proving the theorem that states line drawn from center of circle to the midpoint of a chord meets it at 90 degrees. Right, now they give you this. Now check this one out, right? That's the center of the circle. That's X. That's O. And they give you that. This is A, F. That's point F. That's point B. That's point D. Okay, for 5 marks, find the length of the radius. Find the length of the radius of the circle. How many marks? 5. And they tell you that's 90 degrees. Onliners, are we still there? Are we still there? Beast mode. Somebody's in beast mode already with math. Yo. Let's go. Okay, let's go. Find the length of the radius. So they tell us in the diagram, O is the center of the circle ABD. F is a point that AB equals FD equals 8. They also tell us AB equals FD equals 8 units or 8 centimeters. And OF equals X. Right, find the radius of the circle. So let's go. Let's do this together. AB equals FD. AB equals FD, which is equal to 8. That means FD, that entire side is 8. And AB, that entire side is 8. Okay, now we need to find the length of the radius of the circle. So we know a line drawn from a center of a circle that's perpendicular to the chord bisects the chord. That means that piece must equal to that piece. Yes or no? So if this is 8, that means that is 4 units and that is 4 units. Yes or no? Correct? And if this whole side is 8, okay, let me just see here what we're doing. We're doing that's 8. That means OD. OD, the radius. Find the length of the radius of the circle. So that means they want OD. As it stands, OD is 8 minus x. As it stands. Yes or no? Okay. Let's see, what do we do? And OB is also a radius. Isn't OB also a radius, guys? So isn't OD equal to OB? OD equals OB, which is a radius, which is also equal to 8 minus x. That means OB is also 8 minus x. Aha! So now we use Pythagoras. So OD equals 8 minus x. OD equals OB radius, which is equal to 8 minus x also. That's a O. Now we say in triangle, we're telling the person who's marking, look in triangle FBO. Right. What are we going to be doing here? Pythagoras. So, the square on the hypotenuse, 8 minus x squared. Okay, let's write it out. Let's write it out. Let's say OB squared is equal to OF squared plus FB squared. So OB is 8 minus x squared is equal to OF, which is x squared, plus FB, which is 4 squared. That's given. FB was given. Remember, that whole side was, in fact, you have to also say that AF equals FB, line drawn from center of a circle, line drawn, which is equal to 4 units. You have to make that statement. Line drawn from center of a circle, blah, 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 blah. You know what that theorem is. So here we go. This year we are using Pythagoras. There. So now 8 squared is 64. Minus 8x times 2 is minus 16x plus x squared is equal to x squared plus 4 squared is 16. Now we need to, this is a quadratic equation. So x squared, there's it, minus x squared, there's it, minus 16x, there we go, plus 64 minus 16 is equal to 0. X squared minus x squared is out. Minus 16x. 64 minus 16 is what? 48. 48 is equal to 0. Let's divide by minus 16. So what am I left with? X minus 48 divided by 16 is 4. No, 16 to 3 is equal to 0 over 16 is 0. Therefore, x is equal to 3. They want the radius of the circle. Therefore, OD, which is your radius, that's what they want, is equal to 8 minus x, which is equal to 8 minus 3, which is equal to 5. And there's your final answer. We got 5 marks for that. Like I said, you have to know the circle. You have to know the circle, and you have to know Pythagoras within a circle. Okay. The next question is worth 9 marks, 4, 2, and 3. So there's a 4-mark question, a 2-mark question, a 3-mark question. Right. I hope you all got this down. I hope you all have this. Next diagram. Here goes, guys. We're almost there. It's 20 to 3 already. We're finishing up at 3 o'clock. So, come on. We're into the last stretch. Hang in there, guys. Hang in there. Super proud of you.
Comment?
Brain is finished. Last 15 minutes, guys. Last 15 minutes. Hang in there. Brain fried.
I can smell something burning.
I'm telling you. Let's go. Let's go. Okay. Now watch this. So they give you something like that. And they give you something like this. There we go. Automatically we can see. Come on, guys. What theorem does this refer to? Without even doing the problem, without even looking at the questions, nothing. From the theorems that I gave you, which one does this look? What does this look like? 2 tangents meeting at a common point outside a circle. Am I right? So it's there. That's one of the ways in which you're going to get to the answer. So wait, we're not yet done. It looks a bit rough, this diagram. So we got this going to there. We got this coming down here. Take it down with me, guys. We got that going to there. Now we got this going there. We got that coming down there. And we got that going there. These are not straight lines. So S, M, M1, M2. That point is point V. This point is point Q, Q1, Q2. That's 70 degrees. This is point P. This is R, R1, R2. Okay. Now pay attention, guys. Pay attention after you've taken it down. What did I tell you? How do we solve riders like these? These are called math riders. I don't know why, but they're called riders. Right. Okay. We start with the known, moving to the unknown. That's V. That point there is V. That's M. That's S. That's R. That's Q. That's 70 degrees. Right, now listen to me. Listen. I'm not even going to look at the questions. Hear me out. What do you know? Immediately check this out. M is the center. Check here. We know that this side is going to equal to that side. Look at the amount of information that's given on this diagram. Right. And what would the reason be here? 2 tangents meeting at a common point. Am I right? Check this out. We know that that side is equal to that side. Radii. We also know that this is an isosceles triangle. So we know that that angle there is equal to that angle there. We also know that this is 90 degrees. We know that that is 90 degrees because the radius is 90 degrees to a tangent. We also know that this side here is equal to that side there. Actually, it's 2 lines and 2 lines because it's equal to this radii. So we also know that that angle there is equal to that angle there. We also know that this side is 90 degrees. We also know that that side is 90 degrees. Come on, guys. Come on. We fill the diagram already with our answers. We don't even need to look at the questions. The size of angle R2. Right. They want, question number 1, they want angle R2 for 4 marks. With reasons. Question number 2, the size of angle Q1 for 2 marks. Guys. And number 3, the size of angle M2 for 3 marks. 4 and 3, 7 and 2 is 9 marks here already. Now we know, guys, that because this side is equal to that side, that is an equilateral, isosceles triangle. So we also know that this angle R2 is equal to that angle Q2. So how do we answer question number 1? We're going to say QP equals RP. QP equals RP. 2 tangents meeting at a common point. Therefore, triangle PQR is isosceles. Therefore, they want R2. Angle R2 is equal to angle Q2. The angles opposite the equal sides. Angles opposite the equal sides of an isosceles triangle. Right. Therefore, angle R2 is equal to, so you're getting marks for all of this. That's why it's 4 marks. Therefore, R2 is equal to 180 minus 70 divided by 2, because these 2 angles are equal. And that is sum of the angles of a triangle. So therefore, here's your final answer coming up. Angle R2 is equal to 180 minus 70 is 110. 110 divided by 2 is 55. And there we go, we're done. We got our first 4 marks. So now that you got your answer, guys, now that you got your answer for both these angles, go to it and put it there 55 degrees and put there 55. It's so simple. It's so easy, guys. Right, let's find angle Q1. Where's Q1? There's Q1. Come on. What did we identify? That Q1 plus Q2. Q1 plus Q2 is equal to 90 degrees. Yes or no? We said that from the start. Because a radius is 90 degrees to a tangent. So how much is Q1? So Q1 plus Q2, we got Q2, 55, is equal to 90. So here's our answer for the second one. Q1 is equal to 90 minus 55 is 35 degrees. And there we go, 35 degrees. Q1 is 35, that means R1 is also 35. They want angle M2. They want angle M2 for 3 marks. Let's find angle M2. Now those are not straight lines, so we can't say vertically opposite. You can't say M1 is equal to M2 vertically opposite. I don't think you can. Oh, they also give us one more thing. They also give us one more thing, that Vs is equal to QR. Equal chords, right? So they tell us that Vs 1, 2, 3 is equal to QR 1, 2, 3. So that makes a hell of a difference because these two triangles are now congruent. Yes or no? What would the reason be? Side, side, side angle, angle, or right angle, hypotenuse, side? Which one? You can see side, side, side. So now we have to prove congruency. That's why it's worth 3 marks. So in triangle VMS and triangle QMR. Right. Number 1, MS is equal to MR. MS is equal to MR radii. The other radius is VM is equal to MQ. Also radii. And then they told us that VS is equal to QR. Given. Side, side, side. Therefore, triangle VMS is congruent to triangle RMQ. Side, side, side. Right, now we know that M1, remember, R1, angle R1 is equal to angle Q1. Why? Because triangle MRQ is isosceles. Therefore, angle R1 is 35. Therefore, M1 is equal to 180 minus 35 plus 35. So, 35 plus 35 is 70. 180 minus 70 is how much? 110. Hey, we don't even need to do all this. Guys, wait. Let's get, no, from that bottom part. There's a shorter way. Come on. There's a shorter way. This is a kite. What do we know about the opposite angles of a kite? A supplementary, am I right? That's 70. How much must M1 be? 110. So M1 is equal to 110. Why? Because PQMR is a kite. PQMR is a kite. And the opposite angles of a kite, opposite angles are supplementary. They add up to 180. So if that, and these two are congruent. So therefore, if this is 110, therefore, M2 must also equal to 110. And there we go, we are done. Did you see how it helped us to complete the entire diagram even before the question started? Let's do one more, guys. It's 53. Let's do one more question and then we're done. One more. Getting there now. Let's see. Okay. Right, I'm clearing this. Last one, guys. Last one for today. We're on to the last one. Come on. Clear the frame. Good boy. Right, let's go. Take this one down. There we go. Here we go. And there. And we're going to, that's in the middle. We're going to go from there straight across to there. We got a line coming from there down here. We got a line going from here straight across there. So that would go till there. That's O, O1, O2. We got a line coming from there across here. We got a line from there coming across there. This is Q1, Q2, Q1, Q2, R. That is X. Now we're not dealing with values anymore. We're not looking for angles. Now we're proving stuff. So that's S, S1, S2, S3, S4. There we go. Right. They tell you POQ, that's P. POQ is a, listen, okay, just take all this information down. POQ is a diameter. I'm going to teach you how to do this. It's so easy. QS is equal to OQ is equal to QR. They give you that. And QRS is equal to X. So QRS is equal to X. We got that. QS, where's QS? QS is equal to OQ. Okay. Is equal to QR is equal to that. All right. POQ is a diameter. Right. Let's see. Now listen to me. QS is equal to OQ equals QR. Let's fill out as much as we can before we even start with the questions. Check here. Obviously, that side is equal to that side is equal to that side. But this side here is a radius. So it's also equal to OS. It's also equal to OP. Because they are all radii, am I right? Okay. What else? POQ is a diameter. They're already telling you use a theorem that talks about your diameter. Which theorem that we did earlier has a theorem that has a diameter in it? Isn't it a diameter subtends a 90 degrees? Yes or no? So let's go. A diameter subtends a 90 degrees. That means S2 plus S3 is 90. Okay, let's look at the question. Question number 1. I want 3 angles equal to X. Find 3 angles equal to X. Find 3 angles equal to X. Question number 2. Find O2 in terms of X. And the last question, find the value of X. Okay, let's find 3 angles in terms of X. Come on. Right, this is an isosceles triangle. Can you see it? QRS. We're starting with X, the known. What is special about this triangle? That side is equal to that side. Yes or no? Because it's given. So therefore, S4 is equal to X. Right. So I'm going to answer question number 1. So this is how you write it out. Listen to me. QR is equal to OS given. Therefore, triangle QRS is isosceles. Therefore, angle S4 is equal to X. The angles opposite the equal sides. Alright, there's your first angle equal to X. Now relate this S4 to another angle. Come on. We can already see tan chord theorem. Tan chord. Which triangle am I looking at now? I'm looking at PSQ. If that is X, angle OPS. Other people stompies. Therefore, angle OPS is also equal to X tan chord. We need one more angle. The question says find 3 angles. It's worth 6 marks. Can you see how easy is it? We're not throwing away marks. Now remember, this was a radius. That's a radius. So now we're going to say, we got one more. I got 1, I got 2. Isn't S2 also equal to X? Because that's also an isosceles triangle. So now you're going to say OP is equal to OQ, which is equal to OS, radii. Therefore, triangle OPS is isosceles. Therefore, angle S2 is also equal to X, angles opposite the equal sides of an isosceles triangle. And there we go. We got our first 6 marks. Find 3 angles in terms of X. And the minute you found it and you know you're right, you go onto the diagram and you insert it. Why? Because we're going to be using it in the next couple of questions. We're almost there, guys. We got another 2 minutes, 2 to 3 minutes to go. And we finish. I want you to do number 2. What is O2 in... come on. This is baby work, man. O2 in terms of X. What is the relationship? Come on. Relationship. What is the relationship between angle O2 and these X's? Isn't it exterior angle of a triangle equal to sum of interior opposite? So I'm answering question number 2. You're on the top. Angle O2 is equal to X plus X, 2X. Exterior angle of triangle is equal to the sum of the interior opposite angles. Come on, look at the last one. What do you think? How much is X, guys? No, not 60. Somebody said 60. No. No. Come on, something you're not seeing. Why did they tell you to calculate O2? O2 was 2x. Listen. Check this triangle out. Check here. OQS. OQS. O2 is 2x. And that side is equal to that side is equal to that side. Isn't it an isosceles triangle? That side, they told us, was equal to that side. And that side and this side are radii. So that means these 3 sides are equal. So therefore, in an isosceles triangle, each angle is how much? 60 degrees. So how much is X? 2x is equal to 60. X is equal to 30. Find the value of X. And there we go. That brings us to the end of the 2 days. Boys and girls, give yourselves a nice round of applause. Well done, well done, well done. Boys and girls, we just wait for our onliners. Thank you so much. We have to knock off now at 3 o'clock on the dot. See you guys. Assalamu alaikum. Thank you all for attending. Remember, it will be on the Awqaf website. Jazakallah so much. Thank you guys all. Thank you so much, onliners and on-siters. Assalamu alaikum wa rahmatullah.
Okay, guys, don't go yet. We have Tahir that's on the session. Tahir is going to have a brief chat there with Mr. Khota. And Tahir, it's over to you. Assalamu alaikum. Tahir is one that's also involved.
Walaikum salam, Mr. Khota. How are you?
Okay.
Tahir's audio on?
I think they just want them to share the screen. They couldn't see that last part, the onliners. If they could just share our whiteboard. We're getting the comments coming in here to please share the screen.
Let's do this. Let's just minimize your screen. There we go. Okay,
There we
Tahir,
go.
can we hear you? Is your audio on?
I can hear you. Can you hear me?
Oh, we can't seem to hear you there, Tahir. Let's try and see if we can get you on. Okay, so we are going to be doing the vote of thanks. But before we do that, let's see if we can get Taya. Taya, you are unmuted. Let's hear your voice.
Can you hear me now?
Oh, we can't seem to hear you. Anyway, Taya, let's try and do our vote of thanks here. Okay, over to you, Mr. Khota.
Okay, boys and girls, ladies and gentlemen, just want to say Jazakallah, thank you all for attending the 2-day session. Like to thank Awqaf for making this possible, Mr. Baker for allowing us the opportunity and privilege of using South Peninsula here in Cape Town. We hope to see you guys soon. Lots of love for you guys. Inshallah, you guys will do well in this exam. You'll master all the notes and you'll come back blazing with distinctions at the end of the year. So we'll be in touch with the school. We'll be trying to find out exactly from the school, exactly how have you guys been doing. And inshallah, we will mentor you right through until the end of the year. For our online learners, thank you all. Thank you all to your schools for all participating. Remember that this 2-day workshop will be put up on Awqaf's website. It's live already. You guys can just go to www.awqafsa.org.za and you can click on the links. The workshops are there. Go through it over and over and over until you master all the processes. From me, Mr. K from Kway Institute, South Africa, I'd just like to say, Jazakallah so much, lots of love from us, and God bless.
So there we go. Thank you, Mr. Khota. So what we would like to do, we'd like to thank, and I think Mr. Baker would also like to get you over there on that side by the banner wall there, Mr. Khota. You would like to, and we're also going to give Mr. Baker an opportunity to speak. So if we can just get our mic here, over here at the big banner wall, would like to thank our team behind the scenes. Taya, unfortunately, she could not join in, but she's been involved with moderating lots of your comments, and you'll see her on future workshops. She will be the host. Thank you so much to Samit and their team. They've been doing a fantastic job. Thank you to the Department of Basic Education. Thank you to all of the online learners that have logged on, their parents, as well as educators that have ensured that they've been able, or some of the learners have been able to log on to the session. Thank you so much from Awqaf. You've been an amazing cohort of learners here at South Peninsula. Thank you to Spine Road, Livingston, Oaklands, Islamia. Thank you so much. Over to Mr. Baker. We'll give him a chance to speak.
Okay, Oaklands would also just come to the front, please. Oaklands, are you here? All right, so students, those of you who are here for both days, you will agree with me that the 6 hours yesterday, 6 hours today have been absolutely amazing. And I'm sure that both of you, well, for both days, I'm sure that you've benefited and that you would apply whatever you've also learned today. Obviously, the teachings of your maths teachers, that will also be crucial in your preparation for your maths exams. So just on behalf of the schools that are present here today, we would like to just, there's a small gift that we would like to give to Mr. K and also Mr. H. Firstly, Mr. K, could the two students, it's Livingston and South Peninsula, just a gift on behalf of the schools present. And then we have Islamia and Spine Road. They've got a little gift for you also, Hasnain. All right, and if those two students could just remain in front here, we just want a picture with the presenter as well as the coordinator. Students, I know you want to get home and enjoy a little bit of your holiday and also maybe a little bit of celebration after the Springboks winning the rugby yesterday. They are the world champions once again. They've retained their title. They've won it 4 times. So students, to all of you, well done. I'm extremely proud of all of you for the 2 days that you've sacrificed. You have shown me that you are willing, that you are prepared to make a difference as far as your maths is concerned. So to all of you, thank you very much. Go home, drive home safely, and I'll see you tomorrow. Thank you.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Awqaf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Awqaf can bless our community with a